Hello and welcome to Python Fundamentals, probably the best Python beginner course on the internet. Free on YouTube in its entirety of 5.5 hours with no ad interruptions. My name is Sanyan, I am the course creator, and I'm going to tell you a little bit about the course. So the very first module is called Python Core Concepts, and these are variables, data types, loops, and if statements. So with these, you can already begin to construct useful and interesting Python programs and build from there. So after that, we get into functions. And we look at functions both as ways of solving a particular problem with parameters and return values, but also as a way of organizing our code so that it's more scalable and you can make larger programs. Next, we have dictionaries and lists. And these are probably the two most useful Python data types, given that Python is really a language that's all about manipulating and visualizing data. So once we've completed these, we get to have some fun. So that is the fourth module called Programs and Applications. So the first of these programs is an authentication program. This is sort of a usual construct: username, password, a while loop with a boolean. That is a construct often used in games. So next we move to a guess the number game, which is a classic sort of computing programming problem. You generate a random number, user guesses, user gets feedback, and if everything works as it should in terms of user having a strategy, it's exactly the same as a binary search algorithm. The next game is the reaction time measuring program, where a user gets a random go signal and then reacts and gets their time in milliseconds. This is a lot of fun to play with friends. After this, we move into some text analysis. So we have this word ranking program, and the word ranking program reads an entire book and returns the ranking of the most common words. If you do some filtering to those words, you can basically have a ranking of the protagonists of the book before you've even read it. Last, you have a much sort of larger file that's in with pretty much most of the English words out there, over 10,000, and you run an algorithm through it trying to discover palindromes. So with this program, we discover a majority of the palindromes in the English language. Those are basically words that are spelled same forwards and backwards. So our final module is all about encryption. Now, this is a real nice application that puts together everything we've learned: dictionaries, lists, functions. And at first, we're just going to write an algorithm in a program that encrypts text using Caesar Cypher, which essentially consists of shifting words several number of places, or whatever shift we want, in the letter order. This is what an initial program is going to look like. You get a message, goes through the algorithm, and gets out encrypted. But after that, things get interesting as we write programs that break this encryption, as well as programs that write more advanced encryption called polyalphabetic ciphers. So I should also mention the free resources that come with this. Very important, I guess, timestamps for every tutorial. So if you've had enough of me lecturing and you want to skip to the part of the course that's super interesting for you, you can do that. Timestamps are in the description and in the comments. Also hosted on my site, there are interactive program links with REPL, so you could basically get into the code in seconds for any program that you're using. You can also download the Python files and the PDF handouts. Last but not least, I am planning to make the comment section of this video very, very useful. I will answer every single comment in detail, so please ask questions. So before we get into Python itself, I'll tell you a little bit about me. So I'm originally a robotics engineer. I studied mechatronics systems at uni, and pretty much for my entire adult life, I've either been in technology or education. So for the past 8 years, I've been teaching Python and working with teachers to develop curriculum that is used in many Australian schools. So a lot of the tutorials that are a part of this course are actually being used by tens of thousands of students. Now, this is actually a fairly good standard for what I think should be education. Like, if students who don't have a technical background, who are not necessarily enthusiasts or particularly talented, are getting value out of these tutorials, then probably so should most people. I've authored a number of books and online courses. A number of them are free, so they're also going to be in the description, as well as more of an extended profile with some links to teacher training available that I currently do. So if you're a teacher, check those out. Okay, let's move on. A little bit about Python. Now, why is Python the most popular programming language for beginners? Well, that is not an accident. Now, Python starts in 1989 as a hobby project for this guy, Python creator Guido von Rossum. And his idea is essentially something like Esperanto of programming languages. If you're not familiar with Esperanto, Ewan had this dream of creating a language that everyone in the world could learn so everyone could communicate. Well, Ewan couldn't do it, but Python Foundation more or less succeeded because Python was seen as a glue language that would help interface complex databases written in various other programming language. So every programmer could learn Python and use it to fuse different systems together. By 1999, Python had come along quite a long way. And there is a famous proposal that they sent to DARPA. Now, I don't think they got very much money from DARPA, but this proposal sparked a revolution because they said essentially, here we have a programming language that kids can learn in high school, computer programming for everybody. So this went on to light a spark that created code.org and many modern today's coding initiatives for various students. And since then, really, Python has slowly taken over as the programming language beginners learn. Now, what is Python mainly used for today? It has to do with advanced analysis, manipulation, and use of data. So scientists use it for to publish their results, analyze their results. Again, with this advanced statistical analysis, it's perfect for artificial intelligence and machine learning because all of that learning is tied to data. And a lot of other developers use it to sort of develop quick prototypes because it takes less time and less lines of code for a Python project than one written in a sort of more systemic language like Java or C++. Now, I've probably mentioned a little bit. One of the best things about Python are the libraries that are constantly coming out and evolving in the Python community, which is creating these in an open source way. Some of my favorite ones, and probably some of the most popular, are SciPy, NumPy, and Matplotlib. Now, these are used equally by scientists, statisticians, data scientists, as well as sort of machine learning researchers. I also like NLTK and TextBlob because my passion and interest is creating chatbots with Python, and these two libraries specialize in that. Okay, so let's start with some theory here before we write any code. You can think of Python or any programming language as a system that manipulates values. What do I mean by values? Well, you've got numeric values, which are just numbers. They could be integers or floating point numbers. And you've got string values, which are text. Now, in Python, typically you either got strings, double quotation marks, or in single quotation marks, or you've got docstrings, which are used for multiple purposes, but they allow you to have basically longer bits of text. So you're going to go around and manipulate these values, and one of the ways to do it is to save the values as variables. So this works much the same way as maths. You can have an x equals to 20, and what that does effectively is it takes a value of 20, puts it in a box that exists in memory with the label x, and it assigns a type to it. Now, a type is a category of data that a value is. X is an integer, and in this other case, an example, it's Bob, and Bob is a string. So I mentioned how Python assigns types. So this is an example of some Python code. If I say a equals 10, I could say type A, and it turns out that a is an integer. In other programming languages, I would have had to specify int a equals to 10. And this is called dynamic typing. Python, again, is built to be easy. You can get in trouble with dynamic typing on complex projects, but it's really convenient and works rather well. So some other examples of dynamic typing here are pi, which is a floating point number, or a name variable, which is a string. If you had a more complex type like numbers, and there's a list of numbers there, it's the class list. Okay, so we've covered values, we've covered data types. Now let's talk a little bit about expressions. So an expression is essentially something that contains multiple values with some operators. So you could have an addition expression, a plus b, subtraction, multiplication, division. All of these we are going to be tackling in our very first coding tutorial. So let's get into it. Hello and welcome. My name is Sanyan, and this is the very first tutorial in Python fundamentals, where we get the handle on the Python interpreter, the variables, and the data types in Python. So our learning intentions for this tutorial are to know what the Python interpreter is, to know what expressions are and how to evaluate one, to know what variables are, how to create one, and to be familiar with the different data types that can be stored in the variable and how this happens inside Python. If that sounded a little technical, not to worry. I promise these things are going to make sense in about 7-8 minutes. So let's start with the Python interpreter. What is it? Well, these three lines that you see right there, they're called a chevron, and they're essentially Python saying, give me some text and numbers, and I will tell you if it makes sense to me. So if it's Python code, or perhaps if it's some mathematics, Python is going to process it and give us an output, or it's going to save information. It's going to do something useful. If it's something that Python does not understand, then we're going to get error messages. So if we say hello, there we go. We started a Python course with an error message. I think that's original. And if we say, who are you? And we're just going to get invalid syntax. So essentially, you can't type random stuff in there and expect it to make sense with Python. But what you can do is do some maths. So if we say 1 + 1, there you go. Python knows that that's 2. Now, incidentally, this handles our first 2 items in the glossary. This is an expression. An expression is a combination of variables, operators, and values. Some of these. What we have here, 1 is a value, that plus is an operator, and 1 is a value. And that evaluates to a single value, which is number 2. So in other sort of arithmetic operations, maybe I can just show you some. So you can say 2 times 5. So the star is the times, and the divided is the sort of dash right there. So as you can see, these are all expressions. They evaluate to a single value. What is next? Well, what is a variable? If I did this, x equals to 5, and then I said x plus 2, most of you would tell me the correct answer right there. That is 7. But what actually happened is fairly important. What we have is this equal sign. That is an assignment of a value to a variable. In other programming languages, this was actually symbolized by an arrow. And if there was an arrow on the keyboard, I guarantee you we wouldn't be using the equal sign. So you can imagine there's an arrow pointing. We're putting the value of 5 into a space in memory that is x. So x is now storing 5. And there you might have seen in programming x double equals 5. Double equals is more like an equal sign. And this is basically going to tell you if this, if x contains a value 5, it's going to return or evaluate to true or false. So we can do a couple more mathematical operations. We can say x times 6. And we can maybe go 3 times x minus 2. By the way, this is BODMAS is in operations here. So if I said, 4 plus 5 times 3, this is going to not be 27. It's not going to be 9 times 3. It's going to be 4 plus 5 times 3. The 5 times 3 is going to process first. And these are BODMAS rules. So again, to reiterate, all of these are expressions that evaluate to a value. X is a variable. And when you hit X, it's going to say the value of that variable. The double equal sign is much more like the equals in maths. The single equal sign is an assignment. Number 5 is assigned to X. So next we can cover data types. And to do that, you can just do a little thing and you just go type X, right? And X is a class int. So integer in mathematics is just a whole number. In programming, likewise, we're talking about numbers without decimals. But if I said, and this is kind of cool, x equals to x over 3. So you notice how this, again, the equation wouldn't make sense. But when you think, the new value of x, the x value, is all of a sudden going to become a third of what it used to be. So x is going to become 5 over 3. And it's going to be 1.667. So now when I do type x, something else has happened. So it is class float. What is interesting, in other programming languages, you kind of assign the data type that data variable is. But in Python, it changes dynamically. So a floating point is essentially a decimal number, and it has a bunch more memory storage than an integer. So what else can we do? We can have a variable that maybe I can use just, you don't have to use a single letters. You can say name equals to Sanyan. And that is a different data type. So if I go type name, that's called class string. So the data type is a string, and string essentially stands for text. And the way Python recognizes that something is text, it is not whether you type alphanumeric characters, like letters of the alphabet. It's actually if when you pressed equals, what went in had quotation marks. So you can actually do operations with text. You can go name plus name. Sorry. You can do name times 5. I'm pretty sure you can't do name minus name, even though that should work out to 0. You get an error. So operations that you can do with numbers, some of those can be repeated with strings. So we have right now looked at 3 data types. We have int, or integers, which are whole numbers. And this was an example when x was assigned a value of 5 and we said type x and it was an integer. Then we divided that by 3 and it became a floating point. Then we played around with creating a name, which was some letters in quotation marks, myself, and that was type string. And as you can see, some of the operations you can do with numbers, you can also do with strings. So that is all recapped. I believe that we've covered these very well. If you have any questions, please go ahead and ask in the tutorials. The glossary is also going to be repeated in the previous lecture, as well as there's going to be a PDF file of the entire glossary used in this course. See you in the next tutorial. Hey there, I hope you are enjoying the course. Just a reminder, please do like and subscribe. And if you're enjoying the content, check out headstartacademy.com.au. There's loads more free stuff over there. And also in the links, our Eventbrite page, we are doing several free webinars every month. Hello and welcome. In this tutorial, we are going to create our first computer program. That computer program is going to have a print statement that says hello world. And then we're also going to expand on it by getting some input from a user and creating a custom greeting. So the very first thing we need to do is figure out how and where we can write our program. When we open up Python, idle that is, we get this interactive shell where we can write code one line at a time. And we're looking to actually have multiple lines, and we need a file. So you go File, New File, and that opens up a blank untitled file. Then you need to save it. So you go File, Save As. Personally, I'll just browse to my Python course and save that as Hello World. So now my file is called Hello World, and for my workflow, I can put that on half the screen and have the idle output on the other half. So once we have a program, I can click Run here or just press F5, which is going to run it. So print Hello World. It is relatively simple. In Python 3, you need to use brackets. In Python 2, you just do something like this. Hello world. So most programming languages have something very similar to this. This is pretty straightforward. And when we execute this, we're going to see an output. So this is called a standard output. That is a sort of text output for Python programs, and you can see it here in the interactive shell. So now that we've done that, we can maybe make another print statement, and maybe we can interact with the user a little bit. Hello, human. What is your name? So we're going to have hello world, hello human, what is your name? And this gives us a chance to communicate with the program a little bit, to have a user input, so to say. So we can create a user input by creating a variable, and the variable says name equals to input. And this open close bracket here means that input is a function. We're going to cover functions in a later tutorial, and you will see why these are essential. So right now, that name will have been saved. If we run the program, you're going to see something interesting. You see that the program isn't over. We're not in the chevron. We can type in our name. Now that it's saved, the program is over, but we haven't done anything with the name. But we can now do a custom greeting. We can simply say, hello, and just to remind ourselves, there is this thing called string concatenation. We've added Sanyan to Sanyan and had Sanyan written twice. And this is technically called concatenation. It means adding text to one another with no spaces. Having said no spaces, oops, hello plus name. It'll work for any name. I'm just going to do Bob. Hello human, what's your name? Bob? Hello, Bob. So the way you handle that is you can maybe put a little space after hello, and we have a custom greeting. So you can go through the glossary for this lesson. Name is a variable where we save the user input. String is, we're printing strings the whole time. Everything under quotation marks is a string. Concatenation is essentially adding strings together. The print statements gets the text of the standard output, and the input helps us save whatever user types into the variable name. So those are all the important concepts for this tutorial. And there's one more thing I want to show you, because there are two ways to use the print statement. This, the way that I used it, is just one way. Another way is, let's say the computer wants to ask you, and how, and we can maybe add and plus name plus how old are you? Now, this print statement can be combined with an input statement. So instead of saying, look at this, instead of saying age equals the input afterwards, you can copy that inside that. And what you're going to get is a line where you type your age not down below, but right here. Let's run this thing and I'll show you. Oh, maybe we can have a custom response. Print, and then we can go age plus. Not much of a custom response, but it's good to have one. Okay, sign in. And you see how I'm typing it there rather than anywhere else. And it says 33, huh? So we can clean up the formatting a little bit. As you can see, you definitely want to leave some space there, and we can try it again. And maybe I can be Bobo, and I can be... I added a space in the wrong spot. Okay, one last time. Bit of debugging. Bobo. And Bobo's very old. Okay, there you have it. So we've already done the recap. The very last thing I want to encourage you to do is play with both the formats of having your text type inside the brackets of the input and having it done in a variable form afterwards. See you in the next tutorial. So we have reached a point in our course where we're about to learn if statements. But before I get into if statements, I just want to touch on something that is universal, and that is code blocks in Python. A block of code is some code that is indented, meaning moved to the right after a colon. A block of code happens after an if statement, happens after a for loop, after a while loop, a function, and a number of other examples. So, for example, in this if statement, if x was less than 10, nothing will happen, but if x is greater than 10, these two lines are going to happen. Okay, so let's now take a look at some if statements. This is an example of an if statement. Do you like computers? It's going to take a user input, which is going to be yes or no. And if the answer is yes, then you will notice how there's a colon and an indentation. It's going to say, yes, computers are amazing. Otherwise, it'll say, you're not making any sense. And no matter what, because this is not indented inside the if or the else, it'll say bye at the end of the program. So one thing you should know is that this here is called the if condition, and this is a Boolean condition. So that expression there is going to evaluate to true or false. So the if statement is essentially going to say if something, well, that's either true, and if that statement is true, you're going to do this. And if it's false, you're going to do that. And there is the flowchart that sort of represents the very same thing. The other thing that you should be aware of is with the if and the else, a really common error. For example, in here, you're going to ask the user their name, and there's going to be custom responses to each name. So if you say name is Bob, he'll say, hey, yeah, Bob. Otherwise, he'll say, I don't know you, go away. Now, you could have done something like this. So you have a custom response for Bob, Alice, and Valeria. But if you write this in code, and you're going to see this in the upcoming tutorial, this isn't going to work as well as you think, because each if statement is just checking if something is true and then doing it. But the last if else is essentially a fork. So if you were to say Bob, it would say, hey, Bob, and then it would say, I don't know you, Bob, go away. I'll just explain it a little bit with this chart, which I hope makes a little bit more sense. So each if statement is going to check if something is true and take an action. Check if something is true and take an action. But that last if else is a fork. So for the program previous, what we were looking for is this. And that is achieved by the if, elif, else statement. So this statement basically executes the first thing that is true. So if the name is Bob, it'll execute that. If the name is Alice, it'll execute that. If the name is Valeria, it'll execute that. And if none of them have happened, if none of these, it will run with the else. Okay, let's now get practical with if-else statements. Hello and welcome. In this tutorial, we are going to learn what an if statement is, and we're going to create a simple program with an if statement, which we're then going to upgrade with an if, else statement that takes care of multiple options. So let's just go back to our very simple greeting program. So we can just go and print something like, hello, human, what is your name? And when it indents like that, you know you made a mistake. So we can have name saved as an input, and then I can use inputs in more traditional ways. So this is where things get interesting and we can use our first ever if statement. And this is the structure of the if statement. If inside these brackets is some condition, something that's either true or false. So condition. And if that is true, then whatever is indented here, all of this code is going to get executed. If this is not true, the computer is just going to go to the next line and ignore the if condition completely. So let's make a simple observation here. Name equals to Sanyan. So if name is equal to Sanyan, computer can give me a customized greeting, which I'm going to make a bit interesting. It's you again. So right here is a custom greeting, and here is the end of the program. Or maybe I can just print the end. So if we type in anything other than Sanyan for the name, and by the way, I just assigned Sanyan to the name, and thankfully the error came up. In many programming languages, no error is going to come up, and this is really going to put a spanner in your works. You need a double equals. So a double equals gives you a sort of an output which is either true or false. So just like that example, if x equals to 5, you know, x double equals anything. Bob is either going to return true or false, except Bob is a variable name. So if x double equals to some string, Bob, BPB, that's false. If x double equals to any number that's not 5, that's false. But if x double equals to 5 and it's a perfect match, then that's true. And this double equals is a condition. This is also a condition. X is bigger than 2. That's also true. Okay, so let's run this thing. Hello human, what is your name? And I'm gonna say Sanyan. It's you again, Sanyan. The end. And if I run this and I say Bob, the end. So it simply ignores this line of code. So the way you can add an alternative is else, and then you can maybe do a custom greeting. Print good to meet you plus name. So now if it's Bob, good to meet you, Bob. The end. So the last thing that we have to integrate, if I bring back up our learning intentions, is an if-else-if branching structure. So let's say that this program now can recognize multiple users. Let's say Sunyan, Bob, and Alice are all sort of, familiar to the artificial intelligence. And anyone else is going to get this generic good to meet you greeting. Okay, let's have a look at that scenario. So we have, instead of else, we can have an elif statement. This is going to be just like another if statement, and we can say name double equals to Bob. So that's going to be a custom response. Then you can add another one, and this is, oops, I was going to say this is a good opportunity to do some copying and pasting, and it went wrong. And we can add Alice here. And Bob's going to say, hey, Bob, how's it been? It's a friendly AI. Alice, you are the best ever of all time. And maybe, why not, for the final option, print I don't know you plus name plus go away. Alright. When I teach sort of primary aged students, they always make it the meanest kind of computer to talk to. Okay, let's test this out. So we're going to test all three scenarios. Sunyan, it should be a custom greeting. Hello, it's you again, Sunyan. Good. Alright, we're going to try Bob. Hey, Bob, how's it been? Now we're going to try Alice. Alice, you're the best ever of all time. Great. And finally, we're going to try someone else. I don't know you, someone else, go away. Good, good, perfect. And just one last thing, worth trying out. What would happen if it was if, else? Maybe some of you already know, but then this if-else is a package. The I don't know you, go away is an alternative to Alice. So what's going to happen is that in a system where we should only get one greeting, a custom greeting for Sunyan, a custom greeting for Bob, a custom greeting for Alice, or a generic greeting for anyone else, look what would happen if in this program we said Sunyan. Alright, it's you again, Sunyan. But because this is only an alternative to Alice, it'll respond to Sunyan, and then it'll say, aha, it's not Alice, and then it'll say, go away. And this is why the if, elif, else is the correct coding structure. Okay, that's all. See you in the next tutorial.
Alright, so let's take a look at for loops in Python. The loop right here basically is going to print hi there 10 times. It looks like this. There is an I in there that is an integer. It's a counter essentially. And then there is this range. And basically it starts counting from 0 and never reaches 10. So it counts from 0 to 9, which means that overall there are 10 values for the counter. And this statement gets printed 10 times. You can also indent multiple things, so you don't have to indent one line. You can print, so 3 times, repeat hi there like that. Now, I mentioned the counter earlier. You could print the counter and take a look at what for I in range 0 to 10 does. You start off at 0, you finish at 9. There are 10 values, but it never quite reaches 10. And I suppose worth mentioning is that you can use I inside various operations. So this integer here is actually quite handy. We're going to make times table with it. But, here's a funky high pyramid or staircase. So let's now take a look at while loops. So while loops are less used than for loops, but they're particularly handy in programs that you want to keep crunching or working at something until a particular condition is met. So remember how we had hi there, and now we're going to have like a hello there with a while loop. We start off with x at 0, and we keep going until x is no longer less than 10. So eventually x will become 10, and the loop is going to break, but you're going to have exactly 10 values saying hello there. And here's another example of, typically what a while loop would be used like. And here we have some guess. The user guesses Python founding year. And so long as the guess isn't 1989, the user is going to keep guessing. And when it gets there, it will say, well done. Okay, so let's get hands-on with for loops and while loops.
Hello and welcome. We are finally getting into loops in this tutorial, particularly the for loops. Our learning intentions here are to first write a simple for loop that's going to repeat a print statement. So maybe we can say hello 10 times. Then things are going to get a bit interesting. We are going to ask a user for a number, take that input, and we're going to have to do some conversion. We'll actually run into an error first, and we'll take this user number and return a times table using something called a looping variable. So, for the math students out there, if you're very, very young, this could be handy. Let's start with the basic syntax of a for loop. We write the word for. I in range. And the range thing is strange because I can't really print it. So if we say 0, 10, what is happening right here is that this is a range of integers. Its numbers going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They stop at 9. In other words, 0, 10 basically means 10 numbers, 0, 100, that means 1,111 numbers. That's 111 numbers. So the idea is that you have a start and a finish, but the finish is not included in the range. So this means 10 times. Nothing else to it. This just means repeat 10 times. So what do we repeat 10 times? We repeat whatever is indented. So when I hit enter here, there's going to be something indented, and I can say print hello. And that's going to print 10 hellos. I mean, I don't really have to count it. There's 10 of them. So that is the most basic use of a for loop. In terms of writing it, it would also work if you did it this way. Personally, I'm not a huge fan of abbreviations in when you start to learn programming, because the original way tends to give you more insight into what is actually going on. So next, we're going to write that program that asks for a number and then returns a times table. So we can use the new notation, num equals the input, enter a number, and we're going to have an issue here. A manual way to do this would be basically to say, hey, print num times 1, then num times 2, num times 3, and so on. Now we're going to use the loop to avoid it, but even though I do this, you're going to notice there's a funny little error. So we should be getting, like if we enter 5, we should be getting 5, 10, 15, 20. And look what's going to happen instead. This is really interesting. Enter number 5. 5, 5, 5, 5, 5. So what's going on is that this num here is a string, and it needs to be converted to an integer. So num equals the int num. So right here, it means that in the variable num, we're going to put a new value. We're going to put the value of whatever the user entered converted. This int converts what tries to convert whatever is there to an integer. So this is going to work when I enter a 5. But if I try to convert Bob into an integer, I think we can only get an error. So you can't really convert a string into an integer. You can only convert a number in string form into an integer. So now that we have successfully done that little conversion, maybe we can say print, here is your times table. And time for the interesting little demonstration on what this I is. So if I print for I in range 0, 10, print hello. If I print I instead, you're going to see something cool. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So just like we were printing num times, 2, we can multiply num by I, and then we're going to have ourselves a times table. Obviously, this needs to be indented into a loop, and we can say for I in range. Now, we don't necessarily want to start at 0. We could start at 1, 1, 11. So start at 1, stop at 10, print that. That actually should be it. 7. There it is. So you can make first 100 multiples if you want. You can do 101. Run this and get the first 100 multiples of 11. These are kind of interesting because I think there's like 1 to 1. There's some kind of patterns in multiplications of 11. But anyway, there you have it. The times table works. And just to recap everything we've learned. The for loop is used to repeat an action a certain number of times. You may or may not want to use the looping variable. For example, right here, we print hello in both these instances 10 times. But if you choose to use the looping variable, this looping variable changes. It begins at this value, ends at one less than that value. And if we multiply it by some predestined number, then that effectively is a program that creates a times table. See you in the next tutorial.
Hello and welcome. In this tutorial, we are going to demonstrate how while loops work. And we're going to do so firstly by recreating the last program we created with for loops that makes times tables, but we'll use while loops. And then we'll also use a while loop to demonstrate, say, how you could print out all multiples of a number, say 3, that are under 100. So let's just begin by running the last program. So it shows you, it asks for a number and you say 5 and then it prints out the times table for that number. So really, this is the for loop portion and we're going to keep everything here. So we're going to change this to a while loop. Now, while loops don't have built-in counters, so I'm going to create a counter and say counter equals to 1. And now we can do a while loop, while counter is less or equal to, say, 10. You can then print counter times num. And that should be the basic times table. Except counter isn't iterating. So if I was to run this, it would, not Python, shell run module. If I was to run this, it would create a forever loop. So it would just print 7s forever. I need to be ready to stop it. Shell restart. So you need to also manually, like it doesn't need to be done in a for loop, but you also need to manually say this, counter equals to counter plus 1. So it's very much like a for loop, except you have to manually create a loop variable and manually iterate it. And now Now it should run exactly the same way. So if we enter 5, it'll just print the times table for 5. Okay, so we've done this. Let's have a look at a similar application that will print all of the multiples of a particular number under, say, 100. So we may just copy and paste some code for the fun of it, enter a number, and then you can say, here are all multiples of num under 100. And this should be relatively easy to create. So you can say, while you could have another counter, reset back to 0. No, we should start at 1. While num times counter is less than 100, you can print num times counter. That might not be the prettiest way to do it, because that's sort of a clunky conditional, but I'm sure it's going to work nicely. So let's just start with that times table, and we have the second time to enter a number. So multiples, say, of 3. Ooh, what did we do? We forgot to iterate. Let's restart the shell and iterate the counter. So this time around, it should work pretty well. So we'll get multiples of 9, and then everything that's a multiple of 3 under 100, finishing at 99. Okay, I hope that was instructive into how to use while loops and how to be careful to add counters to these conditions so you can escape getting caught in eternal while loops. Hello and welcome. In this tutorial, we are continuing to recap some of those fundamental concepts, this time around with Turtle. So we're getting some visual outputs and drawings instead of text. Now, we're going to pick up from where we left off. Our last program draws 4 sides, and we specify the length and the angle between them. This time around, we're going to initially put that in a for loop and be able to draw any polygon. And then we are going to look at drawing some interesting shapes whose sides tend to decrease until they get to 0. And that's going to use if statements and while loops. So let's get a quick recap on what this thing does. So if we go into the console and we say side length 120 and side angle, or angle between sides, 90, we're going to get a square. So let's make this more interesting. Instead of side angle, enter number of sides. So right now we can put this guy in a for loop for I in range 0, sides, and that's basically going to give us however many sides we want. We're going to go side length, but rather than the angle here, which is a bit tricky, we should go 360 divided by sides, because we're going to go back to where we sort of started. You want this guy to be pointing in the same direction at the start and the finish. So if I run this, and in the console I say side length 100, and then I say sides 5, not defined on line 6. Because we should have called that sides. Run. Side length 100, number of sides 5. Result, we got ourselves a pentagon. It's going to work for any polygon. I mean, I guess I can go 110 and then sides 8. And we can create an octagon. And then this is going to work for any shape. So
what's interesting with these for loops is that you can have them nested within each other, and you can create interesting structures like that. I mean, so for example, if you copied that and you put that there, and this time instead of left, we just went right. Check this out. Side length 100, number of sides 6. We would actually kind of draw a honeycomb pattern. Just one example. So I think that covers reasonably well for loops. Now let's use while loops. I think they're a bit more interesting. And what I'm going to want to do is to create polygons that kind of narrow in on each other. I'm actually going to copy this code. We're going to put it outside in comments. So if you guys want to play around with this honeycomb pattern, you certainly can. But let's try to create a polygon which uses a while loop to do something interesting. So I'm just going to get that there. And this time around, I'm just going to say while. And you can use an if statement. I'm just going to say while true, which is essentially a forever loop in Python. And what I'm going to do here is I'm going to shrink length by -2 every time this goes through. And if length is shrinking in this loop, then I can say if length is less than 0, break. That will exit the while loop. So right now, if any polygon I create, so if I go, I want a pentagon, that'll be side length of 100, number of sides 5. Watch this out. It's not doing what I told it to, and I think that this length -2 here is just not cutting it. So if I guess I have to say length equals to length -2. And let's try that again. Console 105 result. It should fold in on it. Yeah, that's it. It should fold in on itself. And essentially, this if statement is going to break us out of this forever loop. And you kind of have this wonderful polygon that goes on for a while. Now, with Turtle, you can basically do things like turtle.speed and make that happen very quickly. And you can make, well, you can make interesting things happen here. You see how it says 360 divided by sides? If you take a little more left, turtle.left, I don't know, every line it can twist by 1. Watch this. This time, 150. That makes a kind of cool shape. And honestly, there is an infinite number of shapes that you can make, so I'm actually just going to leave it here, and I will allow you to play. What is going to be very interesting is when we use very similar code together with functions, at which point you can easily play with a concept called recursion in such a way that you understand it reasonably well. So that's what I'm going to do in the next tutorial, and see you guys then. Hello and welcome. So we've reached a point in these tutorials where it's time to consolidate some of the knowledge that we've learned. And it's good to basically go over basic concepts like variables, user inputs, if statements, loops, while loops, in a way where we have visual outputs, as in drawings, this time around. So we're going to do that together with a Turtle library, and we're going to use the REPL.it interface to make that happen. Now, in this very tutorial, we're going to use Turtle to sketch a square. Well, we're going to introduce the turtle library first, then we'll use turtle to sketch a square. Then we are going to use the user inputs in combination with that and recap those. So, first off, turtle. Now, this is turtle reference. You can just Google turtle reference. You're going to get a list of functions. Technically, it's object-oriented is the style that it's written in, so they're called also methods. Method is really a function within a class. And the turtle can do great many things. Now, we are basically going to use about 2% of these, but if you want to make cool visual programs, I really suggest you check out turtle reference. So we're going to start off by drawing a little polygon, and we're going to import turtle. Now, here's some lines. Turtle.forward 100 and turtle.left 90. So I bet you've already anticipated what turtle.left does. That turns left by 90 degrees, and this is actually 100 pixels. So this is just going to draw us a line and then a turn. So a copy of 4 of these is going to essentially create a polygon for us, or a square. Here we go, run, and we're going to have a square. So, as I said, I'm also going to use this to recap user input. So, we can specify the size of that square. So if I create a variable length, and we're going to set length equals to int input, please enter side length. Now I can do this within a loop, but we're actually going to do loops in the next tutorial in a more advanced way. So I'm just going to put that in there and run it. Now, as you can see, there's nothing going on because we're in the console. Please enter side length. This time, I want a bigger one. I want side length 200. When I press enter, you will see the result being drawn. That's excellent. And the other thing that I wanted to do is please enter angle. Now, given that we're always going to have 4 sides, this is just going to allow us to draw, I guess, wonky squares. But nonetheless, angle, angle. So now I can copy that there. And I'm just going to try maybe 2 different ones. One slightly larger, side length, 160, angle 88. So I guess this is going to be an incomplete square with a little bit of an opening. And there you have it. I mean, if I decided to go for an angle of like 120, that would make a triangle, and we would maybe retrace one of the sides. Yeah. So that's the basic introduction to Turtle. In the next tutorial, we are going to introduce loops and if statements and make this a bit more interesting.
Hi there, hope you are enjoying the course. Do comment below because I am answering 100% of the questions and doing so rather quickly. Also, do like and subscribe. Tell the YouTube algorithm that you're enjoying this course and help other people find this content.
Hello and welcome. So the learning intentions for this tutorial are that we're going to take a number from a user, convert it to an integer, just like last time. But then we'll do something more interesting. We are going to create a loop that goes through all the numbers less than our number and checks if those two are divisible without a remainder. So in other words, if our number is 10, it'll divide it by 9, 8, 7, 6. So eventually when it gets to 5, 10 divided by 5 has no remainder. So this means that 5 is a factor. So what our program is going to do in
combining a loop with an if statement inside that loop is discover all the factors of any given number, and then print them out, of course. So let's get started. The first little concept I want to demonstrate is the remainder operator. So if I say, for example, 15 divided by 5, and that's 3. Now, 15 percentage 5, that means the remainder of 15 divided by 5, which will be 0. But if we divided 15 by 6, well, we would get a remainder. 15 divided by 6, that would be 12 and a remainder 3. And that's what the percentage sign does. So 5 is a factor of 15. That's why it has a remainder 0. 3 is a factor of 15 as well. So remainder will be 0. So in other words, every time you take a number divided by a number less than itself, get a 0 remainder, that number is a factor. So let's write this program and have ourselves a little factorization. So print, enter a number you wish to factorize. Now, I think I'm becoming a little bit fond of these input statements. So with the input statements, you do not need to use print. You just have to say num equals to, and as we've done before, what this does is save whatever you enter to the variable num. Now the num is not going to be an integer, it'll still be a string. So we have to convert it. Now, in case you're wondering, it is even possible to do this on one line, but then we're doing 3 things at once and it becomes too complicated. You can take this int and wrap it around the whole input, and it's going to work as well. But I don't like the way that looks. So now that we have our number, we can do that loop. And we need to loop down from our number, or from 1 all the way up to our number. So let's go. For I in range 1, comma, to our number will require num plus 1. And here's what we do. We say if the number we entered, 15 in this instance, is going to get divided by all numbers less than 15, and when that happens, if the remainder is 0, the I here is that sort of looping number. It'll go from 1, 2, 3, 4. And when that I makes no remainder, then I is a factor. Print I. And you can, we're going to clean this up so it looks a bit prettier, but I think it should already work with no errors. So let's have a go. Factorize 15. We should get, yep, 1 and 15, 3 and 5. That works perfectly. And if you want to make this look better, then you can say I plus is a factor. Now this is going to produce an error, and maybe you can already tell me what the error is going to be. Pum 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 pum. If you gotta add things using concatenations, they need to both be strings. Now if I converted that to an int, the same kind of logic follows, and then there's going to be a function for string conversion. And now that I convert that number to a string, we should be able to do that. So let's go 98. Maybe it's got very few factors. No, it's got a bunch. 1, 2, 7, 14, 49, 98. Pretty cool. So there it is. That is our factorizing program. In the next program, we're going to take it a step further, and we're going to combine this with lists. And we're going to try to first figure out if a number is prime, if it's only ever got 2 factors, and then we're going to see if we can make a list of prime numbers. And that there is going to require a nested loop. So we're really taking loops and if statements slowly but surely to the next level. See you in the next tutorial.
Hello and welcome. In this tutorial, we are going to improve on our previous factorization program by doing the following. We're going to add a variable which is going to count the factors. So previously, we just printed them out. We're just going to add something that's going to count them. And we're going to do it because the count can be very significant. If there's only two factors, then that means the number is a prime number. So in other words, our program is also going to test if the number is prime as well as give away the factors. So how do we go about that? Well, we first need to create some kind of a counter, and that counter needs to be an integer. Since types are dynamic in Python, we can just have a counter equals to 0. And by default, it's going to operate as if this is an integer. Now, where are we going to increment or increase the value of this counter? Well, obviously, when a factor is discovered, which is in this operation right here, if the number we entered, 15 in this case, is divided by another number with no remainder, like 3, then we print 3 as a factor. We can also increase the counter. Counter equals the counter plus 1. Now this is called incrementing. And if I can just illustrate it a little bit, it is the new value. So this operation stores a new value into counter, which is 1 bigger than whatever that previous value was. So let's test this out, and now we're going to print the counter. So it should run the same way as the last one, but it'll print 4 at the very end. Yes. So right at the end of this program, we can do another if statement, and we can say, hey, if counter double equals to 2, that is the only possibility, there are no others. If the counter double equals to 2, we can print the number is prime. So since that is num, we can go string num is a prime number. And we can remove this printing of the counter. So let's try this out. Invalid syntax. We're meant to be adding that, so that's concatenating. So let's try that again. Enter a number, 17. 1 is a factor, 17 is a factor. 17 is a prime number. So that's pretty much the entirety of the upgrade we needed to turn our program not only to list factors, but also identify prime numbers. I don't know, we can try it one more time. Maybe 51. I reckon 51 is not a fact. Oh, it is 3 times 17. Do I know any prime numbers 50 and up? Maybe 53. Yes, 53 is a prime number. So that is all we're going to do in this tutorial. In the next one, we're going to handle lists and look at how those work. And the one after that will be back in prime numbers, trying to generate a list of them. This is an interesting activity on which there's a lot of algorithms, and believe it or not, even the value of Bitcoin is tied to the scarcity of prime numbers. That's all for today. See you in the next tutorial. Hello and welcome to Functions in Python. So our learning intentions for this tutorial are: first, we're going to understand the concept of a function. Second, we're going to create 3 functions that do the following. 1, perform a custom greeting. 2, add numbers together. And 3, factorize some number. Now, first to the concept. It's a block of code that has a name.
Now let's create the simplest block of code and give it to name. And then when we call that name, the block gets executed. So what would constitute a block of code? Like a bunch of print statements, hello. So we copy and paste this. I guess there's 5 of them, so we can give them a name. We are going to give them a name, def hello 5. Now the function names end with an open closed bracket. Sometimes the inputs of a function go here, if a function has inputs, but it doesn't need to have any. Now for this block to belong to this function, it needs to be indented. So now this is inside the function hello5. And every time I call or I type in hello5, open close bracket, that block of code is going to get executed. Hello5. Done. Pretty neat. Okay. So what's next? A custom greeting. Well, this one is going to take an input. So we can say def, give that a name, and we can greet. Who are we going to greet? We're going to greet the person. A person is a variable that's not yet assigned, but when we type in the name of a person here, that name will be assigned to the variable person. Or to be more accurate, parameter person. So we're just going to print hello plus person. So now we want to greet Alexandra. I don't know. Alexandria. Typo, but nice. Hello, Alexandria. It works. So next one, we wanted to add 2 numbers. Now that is going to be really similar, except it's going to have 2 inputs. And it's going to return a value. Now printing goes straight to the standard output, but functions can also return a value. And I'm going to show you what that means. So we can say def add nums. And we can have num1, num2. And so we can return num1 plus num2. Dun, 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 dun. Add nums 2, 7. That's going to return a 9. Well, that works. So one very, very important point that I have to make here is if we ran this down there and we ran Alexandria as well, only one of these functions is actually going to print to the standard output, and it's the only one which has a print statement. So even when a function returns something, it will not appear in the interactive shell. Watch. Only Alexandria appears. To print add nums, you'd literally have to manually print them. Okay, one last function. I believe I said we're going to write a function that factorizes a number. So, bit of copying and pasting is due. Dun, dun, dun. This was the code that we used to factorize a number. So how can we make this into a function? Well, I guess since we have an input and the input is num, we can say def factorize num. Now we can put that there, and since we have print statements and we're actually not returning anything, this is going to work. So we can factorize 100, some huge number, 1238. wonder how many factors that's going to have. That should work. We just need these brackets. And let's see what happens. Yeah, 1's a factor, 2's a factor. 619. There you go. 1238. It's only got 4 factors. It's almost a prime. It's about as close as you can get to a prime. It's a multiple of a prime. Okay, that's all you need to know for the functions. I will see you in the next tutorial. Hello and welcome to using functions to organize programs. So in this tutorial, we are going to learn some best practices in terms of trying to make our code as manageable and readable as possible. Now, to illustrate my point, this is 3 of our programs pasted in below. And it looks a little chaotic, even to someone as familiar with Python as myself. So what we're going to try to do is we're going to pack it into 3 functions and introduce a menu. We're going to discuss the importance of descriptive naming for these functions, because to a third person looking at our code, it should make more sense if we choose really appropriate names. And finally, we're going to create a main function, which is, in a way, an overview of the whole program that isn't very, very long. Okay, let's get started. So, first of all, let's discuss what we have here. Maybe create some spacing. So, if I can skip the line skipping and just have 3 blocks of code. So this is our custom greeting program. And factorization, custom greeting, times table. So in order to arrange it in some kind of order, we should have it the same as the menu. So maybe we'll do some copying and pasting later. But what we can do is be able to access any one of these 3 blocks of code by calling a function. So let's create these functions. So what is this one? Def factorization. Now, normally you would enter a number there as a parameter, but I mean, we already have this thing which asks the user for a number, so we don't need that. And remember, we're just organizing this code, not rewriting it. So that's going to be factorization. That's going to be def computer greetings. It's greeting by a computer. Kind of instinctive, and that needs a semicolon, very important. It's indented, so whatever is indented after the semicolon is the function. Whatever is indented after the semicolon is the function. And here is the times table. Okay. Well, looks a lot better already. You kind of see that on top level there's 3 things: factorization, computer greeting, and times table. So up here we can create a bit of a menu. Print, please make your selection by entering a number. I'm sure if you remember DOS, you will have seen some of these. Print, press 1 for. Do we do it this way? No, I think I'll put computer greeting first. Computer greeting. So if computer greeting is going to be number 1, we can cut, paste that there. And I think we can make times table number 2, cut, paste that there. Maybe have 2 spaces. So 2 for times table, press 3 for, what was it? Factorization. Okay. Lovely. So now we can say choice equals the input. Now choice is going to be saved as a string. Your selection. So when we're writing this if statement, we should say something like this. If choice double equals to 1 in quotation marks. Otherwise, we'd have to convert it to an integer, but there's no need to convert it. So we've got if choice is 1, what is it? Computer greeting. Now, we can do if else, but the else will then give you a factorization if you enter Bob. And maybe we will just... We're going to do the basic one and see how we go with time. I may just do a little upgrade. So if choice is 1, computer greeting. If choice is 2, choice is 3, 2, 3. So times table was 2. And factorization was 3. So what we have here is a program that's not quite going to work yet, and I will explain why. I'm going to run it, in fact, and I want a times table. And it says times table is not defined. That's because when we call in the times table, the Python interpreter hasn't seen it yet. So if we put this at the bottom, and run it. Enter a number, 7, and wow, it does a big times table. Times table up to 700, I think. So that works, but that's kind of weird to look at. You got all these functions and then your program runs at the bottom. So the trick to doing this in a neat way is to have a main function. So I'm going to cut that and I'll show you what I mean by that, right? So, and this is like almost a standard in programming. So we're going to have a function called main. And this is like a top level view of our program. So in the main, this is what's going to happen. We're going to give these 3 options and run a different function for each option. Now this isn't going to run quite yet, but remember at the bottom, when the computer has read all the functions, this is where we can call main. Right at the bottom, the very last line of code. And all of a sudden, this is going to work beautifully. 358. 1. I always keep picking numbers that are very close to prime. Lovely. So there you have it. That chaos has turned into order. You have an overview of the program, you've got your 3 options here, and the 3 possibilities are quite clearly defined by very, very useful function names. I would almost say this whole program is so clear, we don't need to create any comments. Okay, that's all for now. See you in the next tutorial.
Hey there! I hope you've enjoyed the course so far. Just a reminder, if you like it, well, press the like button and subscribe. There's a lot more Python content coming along. And also do remember to check out the links. We're doing free webinars on a regular basis. A lot of them are going to be about intelligent chatbots using Python.
Hello and welcome to built-in string functions. In this tutorial, we're going to learn how to use this reference list of built-in string functions and apply one of them to do some spell checking. First of all, I guess it's worth asking, what is a string function? Well, it's a function that exists within Python and that you can use without having to import the module from somewhere or without having to, I guess, write it yourself. So I guess I can start with an example. So we're going to come up with some string that has all kinds of cases. This is something interesting. Okay, so this is an example. I'm using it perhaps because it has all type of casing, and in the worksheet I had to use a much shorter string. So first of all, let's look at bobo.upper. This bobo is just the name of the string. So that's going to return, so to say, an uppercase version of that. Now the original bobo is still unchanged. And obviously, this works on any string. So you can have string equals to A, B, C, D, and you can write s.upper as well. So .upper is a built-in string function of Python. How do you know that something is a function? Well, if it uses brackets, whether they be sort of just open-closed, or whether you put something into them, like the length function, you're pretty much looking at a function. So, bobo.capitalize. This one, capitalize is the very first letter of the string, and lowercase is everything else. As you can see, all of these went down to lowercase, but the T got capitalized. Bobo.lower, lowercase is everything. Bobo.title basically turns the first letter in each word into a capital and everything else into lowercase. Bobo.replace, so replaces the S with a $sign. As you can see, it only did it for the lowercase s's. Bobo.count, R, should be 1. Yay. Bobo.strip, and this is kind of interesting. It didn't do anything, because the .strip function doesn't remove all of these characters. It actually only removes them if they're at the start or the finish. So if we did this and wanted to remove either the little t, this would work, or the capital G from the end. Oh, I meant capital G. Interesting. Okay. Bobo.split. Now, you can split by other characters, but in this form, it basically takes the string and makes it into a list. Lists are something we're going to cover in the next tutorial, so I won't discuss them at length here. This one right here returns how many characters are in the string. So out here are operators and segments. With strings, you can add them like you can with numbers. They just kind of bobo.s. So this is something interesting. A, B, C, D. You can multiply a string. So you could say bobo times 10. That'll be lots of text. 10 times. You can take a segment. Now these segments are interesting because when I say 0, 0 is the very first character in a string. So when I say 3, that'll actually be the fourth one. So it'll be 1, 2, 3, 4. So it'll start with S and end with, I don't know where it'll end, but there we go. S is so. Pretty cool. The dot find function basically finds the first instance of a character. So when I say I, it should return 2. I'm pretty sure, yes, because it goes like this: 0, 1, 2. Okay, and on this page, these are, how do I put it? These are booleans. So these functions return either true or false. So for example, dot is upper. The dot is upper is going to return false because not all the characters in here are uppercase. Excellent. Now, there are other versions. Lower is title. We've already covered title. You can check if it starts with a particular character, if it ends with a particular character.
I'll correct this to say ends with. Oh no, actually, there it is. If it starts with a particular character or if it ends with a particular character. You can also ask is numeric or not. So bobo.is numeric. And that is false. So there is one last example. I promised you guys an application to do some spell checking. So we can do a string, and we just call it S. And what I'm going to do is, I've got an article about color from Wikipedia, and it's spelled the American style, not the Australian style. So I can have a string. I should have put that in quotation marks. Alt P. Oops, not Control P. Alt P repeats what I just typed in. And the whole thing should turn green. So this ought to do it. So S, it's all saved there. So now we can do a string operation with S, and we can say S dot replace, and we can replace the American color with the Australian or English. And magically, color, 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 and so on. Of course, if there was a book and there was a hero like, Harry Potter, you can replace Harry with your own name, and you can mess with this in a lot of fun ways. So that more or less sums it up. Functions are not just things you write yourself. Every programming language has probably thousands. Python does, certainly does. It has thousands of built-in functions that, as we learn more, we're going to learn how to use. This here is not all the Python string functions. In fact, it's only about 20 from a couple hundred. So feel free to look online for Python string functions, but for now, this is all we're going to need in this course. See you in the next tutorial. Hello and welcome. So in this tutorial, we are going to be looking into lists. Namely, we're going to be creating lists, accessing and changing values inside them, adding lists, multiplying them, and finally, what is most common probably in programs, checking if a value is in a list and iterating through lists. To do this, we're not going to need to create any programs. We're going to do it straight in the interactive shell. And we're going to start with some very, very intuitive examples like numbers and letters. So we can have a list, and a list of numbers is going to look like this. These square brackets are going to signify that we have a list. The list itself is a variable, as you can see, and we can have 1, 2, 3, 4, 5. Done. That's a list of numbers, and when you say numbers, there's your numbers. So let's do letters. Letters, again, equals to square brackets, and if we did ABC straight up like that, I believe that these are going to be taken in as variable names by Python, variables that don't yet exist, and we're going to get an error. So obviously, when dealing with letters, we're going to need to create them as strings. So A under quotation marks, B, C, D, and there's a list of letters. Now, accessing values in a list. So letters 0 is going to be A, because 0 is it's the index number. So you literally start counting from 0, 1, 2, 3, 4. And therefore, letters 1 is going to be B, and so on. Likewise, for numbers, numbers 2 is going to be not the second, but the third number. So numbers 2 is going to be 3, numbers 3 is going to be 4, numbers 4 is going to be 5, and so on. So this is an index, this number that we put in here, and it accesses an item or a variable inside a list. So changing values in a list. Well,
right there is a reference to an index, and then you can use that index to assign a new value. And just so that it sort of stands out, we can go 11, something big. So when we look at numbers now, 1, 2, 11, 4, 5. And if we want to do that same thing for the letters, we can maybe change A to 1 or something like that. So if we go letters 0, and then that can be changed to 1. So now that we look at letters, and we kind of have these two hybrid lists. Next up, you can just add them together. You can just say letters plus numbers. And we have one larger list that obviously starts with the letters list and then continues on with the numbers. You can multiply letters. You can say letters times 3. And then you have a list where you have the letters and the list repeats itself 3 times into one larger list. So next thing that's kind of handy, especially in programs, like for example, if you want to check if something's a valid answer, like if you want to check if a user password is in a list of passwords or user name is in a list of usernames, you can just say B in letters. Now that's going to return true or false. So B is in letters, but K in letters is going to return false because K is not there. So finally, we can sort of iterate through a list. Perhaps, like take item by item and print them out. So let's create a big list. And we're gonna, for our big list is gonna, we're gonna have, what are we gonna have? We're gonna have letters plus numbers, and big list is gonna be that. So for item, now this could have been I, but I'm gonna have it as item. For item in big list, print item. And it's just going to go through and go at the first, look at the first item, second item, first item, print it, second item, print it, third item, print it, and so on. So have a look. There it is. 1, B, C, D, E, 1, 2, 11, 4, 5. So there you have it. Those are all the most common operations that we do with lists. See you in the next tutorial. Hello and welcome. In this tutorial, we're going to look at some Python native list functions, and then we're going to apply several of those to basically modify the factorization program to produce a list of prime numbers. So first of all, let's have a look at this little resource that's included with the lesson. Here's a number of functions that you can use. So we've got two lists, numbers and letters. This one right here gives you the length, how many members in a list. This one gives you the highest number. Min gives you the lowest. I mean, if it's words, then it'll just give you the one with the Z in it, or the last one in alphabetic order, and the max will give you the first one. Sum adds up all of the elements in the list. It only works for numbers. Sorted basically lines and permanently changes the list into a sorted order. So this was kind of random numbers, and this is arranged in order. These are just a recap of what we've learned, but that's all pretty important, that you can access elements in the list array. Basically, this is how you access the very last element, and this is how you make the list from, so third element onwards to everything else. Numbers.append, numbers.extend, these are worth looking into. In fact, maybe I'll just recreate this really quickly. So we got some numbers, and we got some letters. So if I write numbers, there's the list. Now if I write numbers.append, and I can add 33. So there's a brand new forever changed list of numbers that's right there, and it has 33 added to it. It's a permanent change. Numbers that extend actually adds two lists together. You could have done numbers plus letters, so, but this is another way to do it. Numbers.extend letters. So you can add a whole list there, and now the numbers is been extended with these letters. Pop is actually quite interesting and useful. It's sort of like a stack. So if you write numbers dot pop, it will return the very last element in numbers. It'll say, hey, C. And now numbers is forever changed. It doesn't have that C. And if you do numbers.pop again, I think it'll just return B, and the new numbers is not going to have B anymore. And finally, you can insert into any position. So you can say numbers.insert. And first you say at which position. So if I want to insert something, I don't know, here, that would be 0, 1, 2, 3, 4. In the fourth position, I can insert anything. And now if I write numbers, anything, 0, 1, 2, 3, 4. So that's actually the fifth position, but it's index 4. So in the index 4, which is the fifth position, this is what I've inserted. So that is that list. Now, let's get to some fun application. Here's a program you're very familiar with. Essentially, if we run it, you'll see what it does. You give it a number to factorize 50. It gives you the factors. But if you were to give it a prime number like 19, it'll actually say, hey, these are factors. 19 is a prime number. So we would like to modify this to produce a list of prime numbers lower than a maximum. So we can, at the start, say, enter the upper limit. And we can have ourselves a variable limit here. Limit, int limit. So we are going to do this for all the numbers up to that limit. So you see how there's this num here? We can now have 4 num in range. Since number 1 isn't a prime, we can sort of take it out of consideration and run this all the way up to the limit. Running it up to the limit, when you include the limit, means going limit plus 1. So what this is going to do, and I'm just going to try it for something low, like 5. This should basically factorize all numbers up to 5. So if we say that I didn't actually enter a number, F5, enter number 5. So it does it for 2, it does it for 3, it does it for 4, and it does it for 5. So we can remove this factor prime number business. And in this position, if the counter equals to 2, this is where we can add prime numbers to a list. So we can call this list primes and make that list. And remember, to add to primes, we use the append. So when a number is primes, we can primes dot append num. And believe it or not, that could work. So of course nothing's happened there because we're not printing it, but the primes is right there. It's actually added all the prime numbers up to that limit 5 in there. So what we can do is print primes and try this out on a larger number. F5, come on. 100. Yep, as far as I can tell, that's certainly correct. No non-prime numbers. Let's strive even bigger. 1,000. But you'll notice, I'm sure that we can find a number
where this actually takes some time. And that wasn't very hard. So there you go. That took some time. Now, it's often a coding exercise at university in terms of algorithms. How do you make this algorithm more efficient? How do you make it faster? And some of the ways to do it is to only consider odd numbers and not to count all the factors. The second is one factor you can break out of this loop and then continue the process. There's also the element of actually taking all possible primes, and instead of adding to that list, you just take all the numbers and then you subtract. So you take all the odd numbers and you subtract everyone that has some factors. So that's all for this tutorial. Just to recap, we have had a look at a list of some string functions in Python, and we have applied those, particularly append, to create an edited factorization program, which now produces lists of prime numbers up to a limit. Okay, see you in the next tutorial. Hello and welcome. In this tutorial, we'll be looking at a brand new data structure called a dictionary. We're going to be creating dictionaries, adding values to dictionaries, changing values in them. However, let's first ask ourselves, well, what is a dictionary? Well, it's a data structure consisting of paired pieces of information. So this is just like having a word and a definition. All the words known as keys in the dictionary are unique. The definitions can actually overlap. Just like, if you had like cup and a mug are separate words in a dictionary, but maybe the definition can be the same. I don't know if that's the best example, but you sort of get what I mean. So let's create a dictionary. I mean, you create this variable by putting two curly braces, and now what we have is a dictionary. And now we're going to create some key value pairs. And the way you do this is you go D equal sign. So what's in here is going to be the key, and what's in there is going to be the value. So like if I said banana, I could write a string over there saying tasty fruit. So right now when we print a dictionary, that's a pairing. But I could also go, hey, D4, and that could be a string on that side, 4. As you can see, you can use string, floats, integers. You can use just about whatever you want. So if I run a dictionary this way, so there is no limitation to what you can put, really. I can go D of 5 equals to 1,000. Not sure what the relevance of that would be, but these are 3 keys, and these are the values. Now, if I was to change the D of banana, the value here would be permanently changed. So it would no longer say tasty fruit. It would say whatever I put in here. Yellow and yummy. So if I print out the dictionary, there you have it. So let's think of a particularly good use case. So like, let's say you have a person, and let's say her name is Jane. You usually use, you don't use capital letters for variable names, but let's keep this real world looking. So Jane could be a dictionary. And this is where we could store information, perhaps about Jane, age, and Jane could be 29. And then we can have Jane. Residence. You could have Melbourne.
Dun, dun. So as you can see, you can add as many attributes as you want. There's absolutely no limitation. 172. Okay, so now that we type in Jane, you have all of these. Now you can just add another one if you want. You can change these values, you know, at some point. Jane. Age. By the way, you could refer to it like this. If you type in Jane age, it's going to say 29. And you can now change it to 30. And now when we say Jane, we've changed that value. So as you can see, you have an example of how dictionaries can be useful, how to create them, how to add values to them, and how to change values inside them. In the next tutorial, we are going to look at a really fun use case, and we're going to make dictionaries of synonyms and basically use that with some imported text. See you then. Hello and welcome. We're going to do a number of new things in this tutorial. Precisely, we'll be importing text files into our program. And text files, I mean, actually in this case, an entire book from Project Gutenberg, Harry Potter actually. We'll be saving them to a string variable and then creating our little dictionary of synonyms, which we're going to use to swap words out. Multiple words in a text, we can put whatever we want in this dictionary. And we're going to print out the final result. So, let's just get through some important notes right here. This Harry Potter text file is in the same folder as my Python file called reading text files. As long as these are in the same folder, this code is going to work. So this right here imports it into Python. This saves the book into a string variable. So if we say type text and we print that, or even if we just, let me close that, print, and there you go, that's a string. So what we can do to make sure that we're not dealing with too much text and we don't have to wait too long is we can take a selection of it. And I think what I initially chose was 5,000 characters. So that would be, you know, if the new tweets are 2,800, and 2,800 times 2, I think that would be 5,600. There you go. So now that's 200 tweets. So, and print that. That is the text. So right now, in order to basically take some words from here and replace them with their synonyms, I guess we're going to have to select the words and then create the dictionary of synonyms. Let's see. Privet drive, I guess, you know, D equals to dictionary. Now, D. And this is where we can have fun with it. So we can have Harry. We can replace Harry with Kid Magic. I don't know. I think that's a cool synonym. So you can actually replace both Harry Potter and Harry. Kid Magic. We can replace Harry Potter. And I wonder if it's ever in all caps. No, it would only be in the title at the very start. So we can have Harry. I guess we can have Mr. or Mrs. Dursley. Grinnings. I thought I would have Ron and Hermione here, but it's only the Dursleys. I think there's Dudley. Okay. D. Dudley. And Dudley, I think, is a really mean kid, so we're going to call him Mean Kid. And just to make these perhaps easier to locate, I can add some extra spacing. Even though this is not exactly what you would do in a book, but what this is going to do is make it easy for us to instantly recognize that what we're doing is working. So we've got dictionary keys and dictionary values right there. Now, how do we go about replacing things? Well,
I'll get to that in a second, but for now, I just want to make sure this dictionary has worked. So yes, Harry, Kid Magic, Harry Potter, Kid Magic, Dudley, Mean Kid. Okay, so time to make this do the magic. This right here prints the text. We need the new text to become this section. So what I'm going to need to do is, and pay attention here, say that the new value of text is now only the first 5,600 characters. So maybe I can just print text to make sure that everything is A-OK. Right, so that's the text. So what we need to do now is replace Harry with Kid Magic. So this can be done by basically doing 3 text dot replace Harry with Kid Magic. But we can do it in a loop using this dictionary and make it so modular and infinitely expandable. So we can say for key, I guess, for key in dictionary. That makes kind of sense. Word dot, or what was it, text dot replace, and what we want to do is replace the key with the value, which is dictionary of that key. Now this looks like it should work, but it's not, and I'm just gonna run it and double check that my prediction is correct. Yeah. Boy Who Lived, Harry Potter. This is a very, very important point, and very likely source of a lot of errors in people's programs. Text.replace does not permanently change the string text. Some functions permanently change lists, some functions permanently change strings, but this one does not. So we have to say the new value of text is the one where the key is replaced with the value. So where Harry is replaced with Kid Magic and so on. So right now, when we run this, there it is, Kid Magic. I'd be curious like how that reads, actually. Kid Magic. Kid Magic Potter and the Sorcerer's Stone. Okay. The Dursleys had a small son, so-called Mean Kid. Okay, that's cool. That's cool. They didn't, I guess, didn't mean kid mixing with child like that. No. Screaming Mean Kid into his high chair. Because Mean Kid was not having a tantrum. Cool. It works perfectly well. So, you can expand this. I mean, we can just go and add D and say Mr. Dursley. Dursley. Hope I'm not misspelling it. And what can Mr. Dursley be equal to? I don't know. Sir... Father of Mean Kid. And we can give him some flares. And just run this one more time. Yeah. Now, as you can see, this can be a lot of fun. I mean, you can actually take any book in the world and replace all the names of the heroes with you and your friends, and maybe change the location names, and then really customize text very, very easily. And pretty much, once you have a dictionary, that's all you need to do it. So that was a lot of fun. I will see you in the next tutorial. Hello and welcome. So in this tutorial, we are going to demonstrate functions with Turtle. And having already done them, we're going to jump in straight to a function that takes parameters. And then we're going to do something interesting. We're going to have a function that makes a polygon call itself. And this is called recursion. So we are going to have a play around with that, and that creates some very, very interesting designs with not a lot of code. So let's get started. Let's just think of
a way we create a polygon using two variables. We've already done something similar. So if we say sides equals to 5 side length, or just length, and now we go for I in range 0, sides, turtle.forward length, and turtle.left 360 divided by sides. So if we run this, we're going to get ourselves a pentagon, and if we make that bigger, we're going to get a bigger pentagon. Or wait, I thought that was 100. Now we're going to get a bigger pentagon. Now we're going to get an octagon, and so on. And it's actually very easy to turn this into a function. We just create a function called a polygon, and the parameters are sides, length. And then we can call the polygon function and recreate this one if we want. I mean, I will recreate a different one, 123, right? So we're going to have a large polygon. We have an error on line 4. Yes, of course. Functions need a colon and an indent. There you have it. That's a decent looking polygon. Okay, so what would happen if this thing called itself? So let's just make a pentagon, perhaps. And if we just, after we draw the polygon, we call another polygon. And this time we say same number of sides, but we say length -2. And this would go on and on and on. You would get to negative length, and then it would start drawing another one. So as you can see, a cool kind of chaos ensues. In fact, recursion is a subset of something called chaos mathematics. So let's we can play with this a little bit more. For example, if we want to have the turtle move a little bit, right? So maybe move like in a circle, like turtle dot forward a certain distance, I don't know, 3 pixels, and turtle dot left 5 pixels, and then if we call a polygon, sorry, turtle dot left 5 degrees forward. I think I found that error without, and there you go. I don't know what that is, but it's kind of interesting. And let's say you want to stop that. You don't want it to become chaotic and infinite again. It's interesting how it's kind of following the same lines, but this time getting bigger. Let's say you want to stop that process at some point. Well, we certainly can do that. I mean, if you have this length there that constantly changes, we can have that as a variable inside the function. I'm just wondering, for example, if we said if length is less than 1, and then we say return false. So the function returns something, so the function exits. I'm not sure this is going to work, but we're going to find out. We certainly can have length as a local variable to a function, and that would work. No, this works great. So there you have it. A great example using recursion, and more importantly, using functions. You can see how easy it is. You write a normal polygon function, you twist it a little bit, go forward and left so that it kind of goes in circles.
you specify when you exit, and then you have the function call itself until basically the length runs out. Interesting applications and a really fun way to recap functions. Okay, see you guys in the next tutorial.
Hey there, I hope you are enjoying the course. Just a reminder, please do like and subscribe. And if you're enjoying the content, check out headstartacademy.com.au. There's loads more free stuff over there. And also in the links, our Eventbrite page, we are doing several free webinars every month.
Hello and welcome to the first of 2 tutorials that I'm going to do playing with Turtle and lists. So first up, I'm going to create a list of colors. And this list of colors, I'm just going to pick 4, is going to then be used by programs that either cycle through colors in sequence or select a color at random. So I'm going to design like a looping, like a spirally square pattern, and I'll either do a for loop or a while loop. I'll see when I get to it. Okay, so let's get started. We're going to import Turtle. We're going to set speed to something reasonably high. Turtle.speed 100. Oops. Then we're going to have a look at doing this sort of square pattern. Actually, I'm going to use a while loop, and I'll start with like a variable. So while x is less than 100, I can turtle dot forward x turtle dot right something higher than 90 so that it spirals. I've arbitrarily picked 91, and x isn't growing. X equals to x plus 1. So yep, there you have it. That's fairly interesting. So I guess I'd want that to be a bit bigger, and I guess I'd like it to end in a fairly square fashion. So I'm going to go for 200. And then we're going to have a look at doing some colors. Ooh, that's really cool. Now I'm going to go for more than 200. I'm going to try to complete it so that the right angles are about there. So let's try 260. By the way, coming up with a great design is a lot of trial and error, and I'm just doing that live. Oops. Bit more. So what I'm looking to do is to have these different wings sort of off the spiral, colored differently. I think we're nearly there. 275, 273, 274. And while that's going, I'm going to create a list of colors which we can then employ in this squarish spiral. And I think that looks pretty nice. So, colors. What colors shall we pick? Green, blue, red, and purple. So let's go green, blue, red, purple. And as we draw like each individual line, we can then cycle through one line green, one line blue, one line red, one line purple. So that could look something like this. So turtle.color. Now this is the American spelling. Australian, it's O-U-R. By the way, I missed the equal sign. So turtle.color. Now we're going to say colors, and we're going to select an item from the list in the following manner. Remember, X starts from 1. So, technically speaking, the first item in the list is 0. But cycling is going to work no matter what. So if I say X percentage 4, that means we're going to take the remainder of this list divided by 4. And so the first one
is going to be 1 divided by 4 remainder is going to be just 1, 2, 3. When we get to 4, we'll go back to 0. Because 4 divided by 4, the remainder of that is 0. And it'll just cycle through them. So that should work. Yeah, there you have it. This is fun to watch. Now, I almost think 275 would have been maybe perfect. And you can also play with the pen thickness. Turtle.pen size 3. Let's just see what this one looks like. Now, there you have that as an example as well. Now, I do think that spiraling it out even more slowly, having the angle less than 90 would be prettier, and I'd like these to be really, really, really narrow. But there's one more thing feature-wise that I want to show you, and that would be how to take a random selection from the colors. So I'm just going to select random and import the random library, and in here I can assign a variable C for color equals to random dot choice from colors, and then turtle.color can be C. Now this is just going to look chaotic and probably not as nice as my previous one, but I actually don't like the thick pen so much. But there you go. These colors are completely random. And that is just another way to use these lists. So I'm going to call it a day for this one, for this particular tutorial. In the next one, I'm going to have a look at using lists of numbers, which are going to be, say, polygon sizes and polygon coordinates. Okay, see you in the next one. Hello and welcome. In this tutorial, we'll continue with using Python with lists, but this time we're going to create lists of sizes and lists of coordinates. Then we're going to import the polygon function that we have created from before, and then simply select some coordinates and some sizes from the lists we have created to create some geometric pattern. The pattern is not going to be that interesting, but it'll certainly show you multiple different ways of using lists in Python. Okay, so let's start with making some lists. So let's think about, first of all, sizes. Now, if these are going to be sizes of the side of a polygon, we can come up with a bunch of numbers that are in between 20 and 100. So 22, I don't know, 55, 3, 82, 95, and I guess 99. Is that 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 29. Okay, so we have some list of sizes. Now, coordinates. Should I call it locations? You can create a list of tuples, but those are actually going to be relatively hard to reference. So you can just write out like 10 integers and you use them in pairs. And I'm going to show you how to use them in pairs. So let's see. This screen is probably about -300 to +300 sideways. So we should keep it to within 300. In fact, let's try to keep it to within minus to plus 300 in all locations. So we're going to start off with minus 250, 200, 15, 189. 289. All right, some negatives, minus 180, comma. I'm pretty good at generating random numbers. Okay, so again, we want 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and minus 99, 10. So we have a list of locations, list of sizes, we have some colors. Now we can re-import that polygon function. I'll literally copy and paste it. I don't want to go through how to create that again. And we can now write a loop that cycles through the colors, locations, sizes, and just draws different polygons. So let's have a think about how do we do that. I think the location is the most challenging. So I'll tackle that first, and then we'll see how that goes. So let's go for I in range, because we have 10 in all the lists, except colors, of course. Actually, if we cycle through every second location, 0, 10, 2, this 2 here signifies that you're cycling to every second. So you start at the first, then you go to 15, then you go to 55, then you go to 180, then you go to that one, then you go to that one. So, again, just to check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So if you go cycle by 2, then you can just say, hey, y equals to locations I. And then you can say x equals to locations I minus 1. Now, given that we're going to go minus 1, we really want to start from the second item in the list. So we're going to go 1, 11. That's going to work. Okay. Now we can say turtle.go to x, y. And just to test it, let's say turtle.stamp. Okay, there it is. Turtle left 1, 2, 3, 4, 5. Turtle left 5 stamps in 5 different locations. So we have gone in 5 different locations, and instead of stamps, we're of course going to draw polygons, and we're going to be neat about it. So turtle.pen up, and then we're going to go turtle.pen down. So I think now those stamps, and they're going to be the same 5 places every time. So we can get to create a random polygon here. So wherever we have the stamp, we can now select a color, and as well as selecting the color, we can select the size. So size for the polygon. So let's do this. We're gonna call the polygon here, and we are going to randomly select, I guess, the number of sides, but we can't have less than 3 or more than 8. So I guess we can say sides equals to random.randint 3, 8. Now we have sides, comma, and locations. Sorry, sizes. We can also do random choice. Random dot choice sizes. All right, that ought to do it. So yeah, you go to those locations that were preordained and you start sketching polygons. Sometimes there's an overlap, sometimes they look quite nice. Okay, and one last thing. We can even fill in with a particular color. So if all of the drawing really happens in that function. So here we can say turtle dot begin fill and turtle dot end fill. So now they're all going to be black after they're randomly generated. And in the very next one, we can select the color for them. So where do we do that? Right before begin fill. Turtle dot color colors. And this time around, I think we should just do random choice. So random dot choice color. All right. And there you have it. Randomly colored polygons that select from lists of colors, sizes, and locations. Brilliant. Thank you very much, and see you in the next tutorial. Hello and welcome to the authentication program. We are, of course, in the applications part of the course. And a really common real-world use case is basically getting access to a database or a system where we need to enter the correct username and password. So we're going to write a program that basically has a valid username, a valid password, and it checks when it asks you for the username, you type it in. If it's correct, it asks you for the password, you type it in, and then you get access granted. We're going to go as far as to have 2 different username password combinations. After that, we're going to have a sober look at our program and have a bit of a talk on how we can improve it in such a way that we can have, an unlimited list of users' passwords and no major bugs. Okay. Let's get started. So first thing we said we're going to do is we're going to have a username and a password. So username, I don't know. I think we had Bobo earlier on. Bobo. Bobo's funny. All right, so Bobo, and Bobo is not particularly sophisticated, so his password is 123, ABC123. And the first thing we want to do is get a username from the user. So this already gets us into the territory of naming your variables. So I guess I can go call it in username or in name. In username. It's kind of long though. In name. In name equals to input. Please your username. There we go. So at this point, we've already saved the username, so we can write an if statement and say, oh, if this is correct, if in name double equals to username, which is already saved, then we're going to ask for the password. Then in password equals to input. Laziness, please enter your password. Okay. And finally we can say, hey, if password double equals to, no. We're going to say if in password double equals to password. Then we're going to print access granted. So this is going to be in password because that's the one we just saved. In password. Okay, so let's check this thing out and see, if I type in Bobo and ABC123. Great. So a couple of improvements that are pretty obvious. If I type in my name, exits. It doesn't even tell you that the username is not correct. So first of all, the else to this if statement. It has to be where? Well, in line with the if. So here, I guess we could put a comment. Else tell user, say user name is invalid. That'll do. So else print that is not a valid username. Okay. And likewise, the in password is saved here, so the else has to be in line with that. So else, I guess we can just say so we can print okay, let's try this. So first wrong username. Not a valid username. Okay, great. Next we're gonna go Bobo, but password we're just gonna power. That's not a valid password. Cool. Okay, so here we are. This is a working minimum viable product, so to speak. So the very first thing that you're going to think, hey, if it's a database, it has multiple users, and all of these users have their own passwords. So I guess we can add a second user and see what that looks like. We're going to need a username 2, I guess, and a password 2. This could be me joining the party, and my password could be passwordy. There you go. Not a great password. So let's have a think about it. How do we first of all let the user get to the next stage? That should be pretty easy. Right here where we're checking for valid usernames, we could say or in name double equals to user name 2. So that should let either Sunyan or Bobo in, and let's give that a try. So, and here's the problem of this program right now, because I can enter Bobo's password, ABC123, access granted. So I guess we need two different combinations. It has to be if username is Bobo and password is password. It has to have both. So in here you would have to say if in name equals to user name and in password. So it has to be the combination. And here we're going to cover for the second possibility and just say elif user name. So we can say 2. And I think that handles it. Let's find out. Invalid syntax, double equals. Thankfully, Python's having none of that mistake. In some programming languages, that error passes, and then your program doesn't work even though it compiles. So let's have a try with Sunyan and passwordy. Sunyan. So we're going to try ABC123 just to make sure that doesn't work. Because if it does, we have serious problems. That is not a valid password. Good. And passwordy. Access granted. So there you have it. As you can see, projecting forward, this would get pretty messy. You would have a long list of usernames and passwords, and this would have a long list of elifs and elifs and elifs. But it can scale up, just not very neatly. It also has the other problem whereby we enter the wrong username and the program exits. So this program should be accepting a username and password all the way until it receives the correct one. So those are the two problems we're going to tackle in the next tutorial. See you then. Hello and welcome. In this tutorial, we are going to have a look at upgrading the authentication program to accept, first of all, unlimited usernames and passwords. Second, to ask the user again if the user got the wrong password or the wrong username, to try again, to try again, to try again. But finally, also to add a time delay to make the system more resistant to hacking, because if you're able to keep trying different passwords thousands of times a second, which a bot can do, then we have a real problem. Okay, so let's start at the first issue, upgrading the program to accept unlimited usernames and passwords. Well, we can use, instead of this long list of variables, we can use one single variable. And we can use a dictionary. And I'm thinking of what we can call it, because it's going to have usernames and passwords. If we call it user passwords, and we make that a dictionary, we can simply enter a username followed by a password. Done. That would be one. Then you can add as many as you want. So you can literally copy this and change what's next. So this can be Bob. It can be, I don't know, AAA. That could be Alice. That could be YOLO. That could be Anna. That could be Block. I don't know. Funny name for a password. I don't think we need the last comma, but there you go. You have 1, 2, 3, 4 different username password combinations. By the way, Python allows you to do this. You could have added a fifth one, and we can try with, I don't know, Dozer. Character from the Matrix. I think he's born in Zion. There you go. These should all work. So you can basically hit enter after any comma, and Python accepts that formatting. So we have now a list of user passwords, and we want all of these usernames to be valid. So we want to go inside this line and have a think about how we can essentially accept all of these usernames. And the easiest way to do it is to just say if in name, in user passwords. That ought to do it. Now, we've lost password and password 2, and we've lost the username. So when I run this, we're going to get into some errors. But basically, the only thing I need to know is if Sunyan is going to get me past the first stage. So it doesn't matter what I enter here. Even if it's the correct password, I'm going to have some kind of error that a variable doesn't exist. But that's good. That's good. So right now, we need to figure out a way to check the password for Sunyan. And this is the beauty. If you go into user passwords, square brackets, Sunyan, that's actually referencing the value of the dictionary. That's referencing 1, 2, 3. And this is one line of code instead of all of these if, elif. Just to show you, we can rewrite that if statement from scratch. So here we go. The password has just been entered, and now we can say if in password, no, oops, in password, if that is equal to user passwords, square brackets of the in name. And that's it. Because if the in name was Sunyan or Bob or Alice, it's going to check the password for Sunyan, or it's going to check the password for Bob. So it's only this password is going to work for Sunyan, only that password is going to work for Bob, only YOLO password is going to work for Alice. So then we can print access granted. So that should be it for the infinitely expandable list of usernames and passwords. Username, we're just going to go for Alice and YOLO. Done. Beautiful. So now that that works, we can go back to learning intentions and go, aha, again, if the username or password is wrong. So, problem with this program is if the username was Tom, that's not a valid username, program exits. We want it to prompt again and again and again. And this is where we use a while loop. A while loop just keeps running while a condition is true. So we can have access granted as that condition. So to show you what I mean, we're going to create a Boolean variable, access granted equals to false. And we're going to keep this thing running. Nope, wrong. Access granted. While access granted, actually this would work, but double equals to false. While this condition is false, keep the loop running. At the moment, this loop is going to run forever, which is not what we want. So if I'll just kind of show you. Let's pick Dozer and Zion, and then just asking for username again. So what we want is to basically exit out of the loop if we've reached access granted. So instead of reaching access granted, we can just go, aha, access granted equals to true. So now that's going to exit the loop, essentially. It will still complete that if statement, but we can have that access granted now outside the loop, because as long as either the username or password is wrong, they're going to keep recycling it this way. So let's have a look at this now. Dozer, Zion, access granted, program done. So let's see what happens if we get the username correct and the password wrong. It goes back to and asking you to enter the username. And we can change this so that it asks for the password rather than the username. So I guess the easiest way to do that would just be to have another while loop. So let's go back here. And this is the part where we have basically approved the username as correct. So here we can create good password equals to false. So that's another Boolean variable. And we can say while good password equals to false. While that's going on, we can keep making this inquiry. And I guess when access granted becomes true, I guess we can make the good password equal to true as well. So right in here, that should really do it. So let's get the correct username and wrong password. Ooh, yeah, shell restart. Okay, a very teachable moment here. I think I know what's going on. Essentially, when this is false, you're not entering any more new passwords. I mean, the good password, it happened above the while loop, so it's just forever printing that's not a valid password. And all I needed to do was just include this part where we're asking for the password, inside the place where, so now we're asking for password inside the while loop. Now also, the good password needs to be false and it needs to happen before the while loop. So I think it's gonna work now. Just to reiterate, this prompt for a password, you didn't have another chance to type it. Once it was typed, it was it. That was the only password. It was always wrong, and it was always printing this. Now, after it's wrong, you will go back to the beginning of the loop, and it'll ask you for your password again. So let's try that one more time. What's going on? In password needs to be indented. Sure. Okay. Sign in, and now wrong. And I don't remember what it was. A, B, C, 1, 2, 3. Access granted. That is a beauty. So perhaps now is a good excuse to introduce you to a new module in Python called time. And we're only going to use one function inside time. And we're going to use it for a very, very real world purpose. Most systems have a purposeful delay of 1 to, 4 or 5 seconds before they allow you to access a database. Because this may allow a hacker to get a bot to try literally millions of username password combinations. And, given enough time, they'll break through the system. But if they have to wait 2 seconds before entering, that's going to make it a lot harder for hackers. So we're going to import time, and before allowing people in, or perhaps right after they've entered their password, we can hear whether they're right or wrong. We can hear print waiting. I'll make it pretty. So this is time dot sleep. So it basically here it does nothing for 1 second. If you choose 1, it'll do nothing for 1 second. And I think this is a cool graphic. I'll show you what I mean. Print waiting. So the next one's gonna have 2 dots. Maybe like, and the last one's gonna have 3. And so we can do that whether access was granted or whether access was denied. So let's try that out. Sign in. Ha! Cool. Now I'm going to leave you with a little bit of a challenge. How do you make the dots appear on the same line? Okay, you try doing that, and I shall see you in the next tutorial. Hello and welcome. In this tutorial, we are going to be creating a memory training program. So the way this is going to work is we're going to get the program to create a random number sequence. The length of the sequence will be determined by the user at the start. Then the user is going to see the sequence, maybe for 1 or 2 seconds, and then the program is going to check if the user can recall it. There's going to be a couple of challenges, one of which is in Python, idle, you cannot delete text. So we're going to figure out a way to hide it. So let's start from the very basics. We're going to need to create this random sequence. I guess we're going to need random numbers. And this time I'm going to use some comments. We're going to have to create a sequence So we're going to create a random sequence. We are then going to show it for 2 seconds, maybe 5. Be generous. And then we're going to hide the sequence. And finally, we're going to check if the user can recall the sequence. Okay, so those are pretty much all the steps. And let's... Oh, one important thing. I'm pretty sure I said we're going to get a sequence length from a user. So we're going to add another one. Get a sequence length from a user. From the user. Alright, this one should be pretty easy. I guess we can call this digits, and that's going to be equal to int of an input. What should we say? How many digits do you want to guess? So that ought to do it. We can then convert this variable into an integer. And that's step 1. All right, random sequence. Well, I guess however many digits it is, that's how we can run the loop for I in range 0, digits. So if we say 5, this loop is going to run 5 times. And what do we want to run in the loop? We need to have some kind of sequence. I think the only way we can create it is outside of the loop. And then inside the loop, we want to append a random number from 0 to 9 to this sequence. So sequence dot append random dot rand int 0, 9. That ought to do it. I'm just going to print sequence just in case. So let's see if this works. We want 3 digits. 479. Great. Let's try 6 digits. Awesomeness. Alright. So that works. Now we want to be able to show the sequence for 5 seconds only. Now, that shouldn't be that hard. I mean, we can time.sleep for 5 seconds. However, how do we hide it? And the only way that I can really come up with is that for I in range, however many lines it takes to hide, I mean, we can pick 30, that should do it. 30 will work, but I prefer to use lower and upper limits. So from 0 to 30, we can just print, you can print nothing. That ought to do it. So let's give this a try. 6. Oh, we did not import time. 6, 2, 4, 5, 3, 7, 1, 2, 4, 5, 3, 7, 1. 30 is not enough. Alright, we'll go for 50. That ought to be pretty safe. 5. 7, 5, 4. Yeah, well and truly disappeared. Now, how do we check if the user can recall the sequence? Well, the same way we add the sequence, I suppose, you can sort of copy that because you're going to have the digits. And then right here, for each one, we can say print enter number at index plus string I. So enter number at index 0, so it'll be the first, This will make sense to a programmer, maybe not to an average person. So you may want to go string I plus 1, I guess, because it'll be the first position, will be the first, or index 0. And then num equals to int of input. And if num double equals the sequence I, if that's true, then we say print correct. And if it's not, then it's wrong. So we should probably just, print wrong. And break, exit out of there. All right. That ought to do it. That ought to do it. I can't see that going wrong, although often it does. 6 digits. Should be easy. Let's go. Oh. I forgot it. Oops. Let's try again. Come on, you can remember 6 digits. One, 8, 5, 4. Yes. So this works. There's a couple of more things you can add. I mean, if you get all correct, you may be able to add a congratulations message. Perhaps if you get the first one wrong, you may give the user a different kind of feedback. I can't believe you got the first one wrong kind of thing. But I'll leave those improvements to you. I think it's a fairly interesting game, and in effect it can be really useful to you. I mean, if you can remember 10, 15, 20 digit numbers, that's a very, very impressive skill. Okay, that's all for this tutorial. I'll see you in the next one.
Hey there! Nice to see you got this far in the course. Please do remember to like it, subscribe, help the other people find that course and help the YouTube algorithm recognize interesting stuff. Also, do remember to check out our Eventbrite page. There's lots of free webinars and free events coming out. That is in the description. And by all means, comment below, ask questions if you haven't already. Hello and welcome. In this tutorial, we're going to work on 3 extension questions to the memory training program. Now, as the program stands, we are currently only guessing numbers, and we want to expand that functionality to both numbers and words. And to do that, we'll import a word list. So just to show you the way the program works, at the moment, it's going to ask you how many digits do you want to guess, and if I say 5, 2, 4, 4, 6. Then I have 5 seconds to memorize that, and 2, 4, 4, 4, 6. That's correct. So instead, I would like to be asked how many digits, or perhaps items, do you want to guess, and then do you want to guess words or numbers? And I want this whole code to be built inside functions, and there's going to be a menu function that gets called at the end of the program, and from that menu function you'll see how the program works. So this is fairly advanced. I would, in this case, probably only if you are confident with functions should you try this on your own, but it's up to you. Give it a go, see how you go, and there's always the solve tutorial. I'm hoping to make it so clear that we're not going to need that many comments. So I've just gotten rid of the previous comments. This is the code. We'll be reusing a bunch of it, and we're going to actually start with this sort of menu and choice right up the top. So let's think about what we want in the menu. We want to start with the same question, how many digits? Since it's going to be involve words and numbers, we can rename that and say how many items do you want to guess? And we can start with our menu here, def menu. So in this menu, we want to ask that question. And then I guess if we're going to call it items, we can rename everything as items. So after items, we are going to be asking the user print type 1 for guessing numbers and 2 for guessing words. I think that's clear enough. And then we can have a choice as input. So right now the user is going to get like a string input of either 1 or 2, and then I can say, hey, if choice double equals to 1, do something. For now, I'll just say that. If so, we could do an else, but the user can type in anything. So we should do 2 if statements. If choice double equals to 2. So right now we have that structure, and in here we're really going to take this whole sequence creation, but we're going to instead create a function that creates a number list. So let's have a think about how we go about doing that. And the function can take in a parameter, so say like def number sequence. And that function is going to take in a parameter, and that's going to be like how many items we have. So we can just call it the same as the previous one, or you can just call it num items. So number of items. And then for I in range, whatever that is, sequence.append. Now, at the moment, this is going to be, see, that's a list of integers. If we're going to have words and we want to compare them equally, I think it would be better to actually have everything, all the sequences be made out of strings, because we want to use the same code here to check them. Do we want to print the sequence? No, we want to return it. Return sequence. Okay, so let's see if that works. We're just going to say, maybe we create a new item. So memory list equals to number sequence, and remember we have items there. And then we can do the same here. The function doesn't yet exist, so we can create a blank, but that's going to be a word sequence, and that's going to have however many items. Can't get rid of that for a while, and then have okay. So we have word sequence, and right now we're just going to treat it blank. Let's have a think if that's going to work. What I want to do at the end is print memory list. So if we are successful, at this point, we're going to call the menu. Right here, we're going to call the menu, And if we select 1, we're going to produce this random set of numbers, except they'll be under quotation marks. So that's our first test. So let's go. How many items do you want to guess? I want to guess 7 items, and then I'll select 1, guessing numbers. Okay, good, good, good. 1, 2, 3, 4, 5, 6, 7 numbers. Good. All right. So so far, we have gone to the point where we have a menu. We select the length, like the number of items, and we're selecting between numbers and words. And right now, we are capable of generating numbers. Next, we're going to learn how to generate words. So in the folder where this file is lies a text file called 1000 English words. So that's going to be attached to this tutorial. So the way we access that is text equals to open, has to be under quotation marks, 1000 English words.txt, and text equals to text.read. Okay, so that's those 1000 English words imported. So now I'm just gonna take this and put that in the word sequence. See if I can work with the same thing. 1000 English words. Okay, I guess I need to bring text in. Call it text input. And in here, we can have items and text. So text input. And then we can convert that text file into a word list equals to text input dot split. So this is going to, right here, we have a 1000 English words. I'm just going to print this text just so you know what it is that we're working with. It's going to crash at some point. Oh, no, it won't. So these are our 1000 English words. The text.split makes them into a list. And then we can use random.choice to just pick random words from this list. So now that we have a list of 1000 English words, when we're adding to our sequence, we can do random.choice and then enter the name of a list or an iterable object, and then that's going to be word list, which we've just created. Okay. I think there's a chance, and by the way, this is the code that we're operating with right now. So there's no checking going on yet. This should work, and this should create a random list of words. Return sequence. Why, mister? Why don't you like this? Not enough. 1, 2, 3. Yeah. That's gonna run. That's gonna go wrong very often. Okay. How many items? Let's say we want to guess 5 words. This time we're gonna select 2. Yes, opposite with vowel written send. Actually, it almost makes sense. Opposite with vowel written send. Okay, so right now we can generate a random list of words and a random list of numbers. So now we need to implement this checking mechanism, right? So I think there was this thing that hides. So let's see what I'm going to put this in, these guys in before the menu. Actually, I'm just going to put this in before the menu. So we're going to show the list and wait for 5 seconds. So this is basically a hide function. And I'm just going to make it a function since we're in the mood of making functions here. and I can say time.sleep. So we're going to show it for 5 seconds, and then we're going to hide. So we're going to show it for 5 seconds and then hide. And then there's going to be potentially an error, but let's see if that works. So I want to guess, and really, we need to get rid of this printing the text. That was just for demonstration. 5 items, 2 for words. And it's going to disappear anytime now. Bingo. Okay, so far so good. So next we need to figure out how to check whether these items are correct. And this is the code. In theory, we can just copy and paste that up there, change variable names. But what we're going to do is put that in a function as well. So we're going to call the function, and we're going to basically cut this. We're going to put it in here, define it as check, paste the code, and then we're going to think about what parameters need to go in. So for, alright. So what does check need to know? It needs to know the number of items. So we can call it num items like before. And that's going to be items here. Does it need to know anything else? It needs that memory list right there. It's generally not, it's best practice. This would work, but if I call this memlist, so when you call the function, when you call it over there, after that, when you call it, we can use items, which is here. We're putting this in the function, and we're putting the full memory list in there. Okay. That could be it. So, let's see. What are we using in the num items is digits. So I need to paste that there. We don't need to convert anything to int. So we just have input. And I don't know, we can call it answer instead of num. And memlist. There you go. That could work. That could work. Let's run it. I want to guess 5 words. There you go. Challenge myself. See back cow help occur. See back cow help. See back cow help occur. Name of sequence is not defined. So somewhere we're saying print sequence. Oh. After menu. That works. We just gotta tell the user at some point print. Well done, you got it right. Okay. And isn't that a neat looking program? You have a number sequence here, a word sequence here. You have this kind of hide, hide the screen because you need to hide that sequence that was shown to the user. And you've got here check. The function names are pretty much self-explanatory. The variable names are pretty good. It almost fits on one page. Just almost. How many lines? 47. Let's test it out. How many items do you want to guess? I'm going to do 5 numbers this time. 52567. Well done, you got it right. So there you have it. It is relatively simple. There's only one best practice thing left to be done, and generally speaking, I don't think the program really needs it, but I will do it because it's a good habit. So for each function that you create, you should have a brief comment saying what the function does. Menu, what should we say? Allows user to select difficulty. Select, I guess you can say select num of items and choose and words or numbers. I'd say numbers or words because that's how it's numbers or words. So what does the next one do? That returns. It's a function which returns something. It returns a sequence of numbers of num items length. Returns, I guess we should say random. A sequence of random numbers of num items length. A sequence of random words of num items length. This one hides the sequence the user needs to memorize. And we can maybe after 5 seconds, and I think this 5 seconds is gonna go really well here. And that works. It shortens our menu. And finally, check. Checks users' answer to each member of the sequence. So I think that is it. I might try to run it one more time, and I'm curious how many lines. 52 lines of code. So there you have it. I think it works way better. I'll just do 3 words, so 3, 2, just to make sure everything works. Age, symbol, aha. So I think we messed it up. We should have put time.sleep before, not after. So one more time, we're gonna select 3 and we're gonna select words. Busy class head. Busy class head. Well done. So there you have it. I'll see you guys in the next tutorial. Bye. Hello and welcome. In this tutorial, we're going to create a guess the number game. So we're going to develop one by one the following elements in code. First, we are going to create a number between 1 and 100. Then we're going to get the user to guess at that number and give him essentially 3 possibilities as feedback. Too big or too small, and finally the correct answer. So the number is either going to be too big, too small, or correct. Once he gets it right, then the program is going to tell him or her how many times, how many guesses the user made. So let's get started. And the first element here is, how do we create a random number? Well, we need to import
the random module. And then in that module, there's a method called randint. In fact, I'm just going to demonstrate it over here. So random.randint and lower limit, upper limit 1 to 10. That one is going to create a random number each time. And there you go. We even have a little bit of a streak characteristic of sort of computers producing random numbers. So we know how to create a random number. We can save this as a variable. We can call this xnum, being that it's some mystery number we need to guess. And now, perhaps even at one guess, let's try to come up with that if statement that is going to check a user guess. So first of all, something very familiar to us would be, hey, I guess we can call this your num equals the input. Please guess a number 1 through 10. So once number is guessed, it's going to be a string, and what we want to do is convert that to an integer. Now, I'm just going to do the integer conversion over here. This is the only time I'll use this line, just for variation purposes. I prefer to do it in a separate line. Your num equals to int your num. But you can basically do it all on the same line. So now that we've created a number that the user is going to enter, let's do that if statement. So what are the possibilities? I'm just going to go too big, too small, and correct. So too big. How do we handle that? Well, if your num is greater than xnum, then print, I guess, you just print too big. That'll do. If your num is too small, then we can do something similar. But we're going to say, hey, if your num is less than that mysterious number, we're going to print too small. And finally, if they're equal, then we can print correct, or well done. Well done, you guessed the number. Now, this could have also been an else. And we can actually shape this if, elif, or if, elif, and remove this completely else, because we are going to deal with an integer. So basically, if we entered something that wasn't a number, we're going to produce an error at the very start. So this loop will receive an integer. So it's kind of up to you. I think the if, elif, else is a very neat coding structure which basically guarantees that only one out of these three possibilities can be chosen. So let's try this out. And we can just print, just to make sure the program works, we can print xnum at the very end. So here we go. There's some mystery number. We're going to try a 6. Too big. And the number was 5. Hey, I wasn't far off. So essentially we have a guessing game. I mean, I can run this again. I can try 2 this time, too small. But I removed that print statement. So let's now see what we can do to have an ability to, keep on guessing until we've guessed correctly. So let's see where we put that kind of while loop, right? It should be just after we've created the mystery number. So we can say
while found double equals to false. So there's going to be some Boolean that's going to stand for the number being found, and that's going to be set to false in the beginning. And I guess that when the number is found, we can either break or make the found equals to true. So both of these are going to work equally well. Either you can say break, or you can say found equal to true. Because when this condition becomes true, that while loop is going to exit, but break is also going to exit out of the while loop. So there's just multiple ways of doing it, and I think it's cool that I show you both. So I think we have pretty much all the elements of the game except the number of tries. Let's see if this is going to work. This should be easy. 5. Too big. Well, 3. It's either 2 or 1. I'm going to go for 1. Yes. All right. So we're going to say you guessed the number. We can also say print. It took you and plus. We can count tries. So right here we got to figure out a way to have a counter for the number of tries. The counter can be outside the loop, initialized to 0. It should iterate every time you guess. So you can either iterate it counter equals counter plus 1 in each of these 3 statements, or you can do it just once right here. Counter equals to counter plus 1. So string counter plus tries. Neat. I think that's gonna work. So I said initially I was gonna do it up to 100, so that's what I'm gonna do, up to 100. Too small. 8. Let's go for a 10. Go for bro. Ooh, it's a 9 for sure. It took you 4 tries. We need to add the space there. All right, let's see how easy it is to crank this up to 100. I think that there does it. And this is also a fun way to think of the algorithm, like the search algorithm, where you sort of halve your result every time. So we're going to go for 50, and if 50 is too small, we're going to try 25. And if 25 is too small, we're going to try 12. And if 12 is too small, we're going to try 6. Then we're going to try for 3. Then it's either 2 or 1. Oh. Wait. I should have gone up. Silly me. So I should have gone to 75, and 75 is too big. So it's between 50 and 75. So then that's 62. Right. It took you 9 tries. I should be able to do it in 6 consistently. So let's try one more time. 50. Now if 50 is too small, that means that it's bigger than 50. Come on, 75. And if 75, it's bigger than 75. So we're going to try for what's between 75. So you got to add 12 to 75. 87. And then we're going to go for 94. 90. It's either 91, 92, or 93. I'm going to try for 92. We guessed the number in 6 tries. So there you have it. That's our guess the number game. It has some neat features. As you can see, it keeps going until you guess the number correctly. It lets you know how many tries you took. And it has, a very neat branching structure, whereby if you enter a number, you will always get to the end of this game if you keep playing honestly. And pretty much the only way this can go wrong is if you enter hello. So you need to enter an integer, otherwise the game's going to fall apart. But
it does everything we want it to do, and it's pretty awesome. Okay, see you in the next tutorial. Hello and welcome. In this tutorial, we are going to take the Guess the Number game to the next level. I've created 3 extension activities, which are a great set of tasks for both you and your students. Once you've created the basic Guess the Number game, you can have a go at doing these all by yourself. And of course, after that, you can have a look at the video and see how I've done them. Both of them have a great many different ways to be implemented. So let's have a look at these extension questions. The first one says, can you have a custom response to a number that is above 100 or below 1, which basically means for a number that is out of range. The second says, can you tell the user if they are close when the number is off by 10 or less? So let's say the number that's the randomly generated number. The randomly generated number is 80 and you guessed 77. It should print out close and then say too small. Lastly, can you create a custom response for a non-numeric input? So if you enter Bob or you write the word 7, the computer is going to respond with, that is not a number. So let's have a look at it. I'm going to get them done one by one, and I'm not going to paste this text in there. I'll try to keep the code as compact and neat as possible. So right here, we can have our first if statement, and that's going to say, is it out of range? So if your num is greater than 100 or your num is less than 1, then print that number is out of range. So given that we don't want this to sort of count in the counter, we can set the counter back by 1. Counter -1. I know this is just one way to do it. We could have put this counter into all the other options, but I don't want this one to count. So if we enter number 5,000, I do not want that to count as a guess. I want that to count as just an invalid input. So if I say 50,000, number is out of range. And you notice how it also says too big. If you don't want it to say too big, we just turn that into an elif. And now it'll be, now I'll go -5,000. The number's out of range, but it doesn't say too small. And I'll just go ahead and play this just to make sure that it actually only counted the proper guesses. 50 is too small. 75 is too small, 85 is too small, 95 is too big, so 90, 93, 92, 7 tries. Look at this, 1, 2, 3, 4, 5, 6, 7. These 2 did not count. So far, so good. Okay, can you tell the user they are close when the number is off by 10 or less? Well, where do we put that? I guess I can put it above. So if the number is off by 10 or less, if you just take the number you're trying to guess and your number and you subtract them. So if you'd say, hey, if your num minus x num, if that's less than 10, then you can print close. Actually, that's not going to quite work, because let's say the number is 5 and you guessed, sorry, the number is 80 and you guessed 5. That's going to be, 5 minus 80, and that's going to be a negative number. So that's not going to work. This is why you're going to need to take the absolute value. So whatever, if you get a negative number, you are going to then convert that to a positive. And if that positive is less than 10, that means you're close. This should work like a charm. Okay, 50, too big. 25. Ooh, the 50 was, wow, we must be tiny. 5. And 5 is close, so we're within 10 and we're too small. 12, 11, 8, 7, and 1, 2, 3, 4, 5, 6, 7 tries. Well done, you guessed the number. It took you 7 tries. It also said close. So if you don't want it to say close, and then you don't want it to say close when you got the answer right, you can just say, and the absolute value is greater than 0. So then it will not say close when you finally get the answer. So what's left? Can you create a custom response for a non-numeric input? Okay, so for that we have a string function that is numeric. So like, let's say we have a string called x, and that string says Sonia and my name. I don't know, the semicolon wasn't necessary. So if I say x dot is numeric, it should say false. But then if that x said was made out of numbers, and then we said x dot is numeric, that's true. Now notice that I said this is a string function. If x was equal to 10, and then we did, that's an error. So in order to use this code, we cannot convert the integer over here. We're going to have to roll that thing back. And over here, we can put if your num dot is numeric. And you can also say double equals to true, but that's unnecessary, because if true, then print. No, if it is numeric, then we're going to do the conversion. Your num equals to int your num. And if it's not numeric, then we're going to print that is not a number. Now, at this point, it's going to continue in the loop, and it's going to try to do some maths and crash. The point is, I need to know, like, okay, so it's working. Too small, 80. And if we enter Bob, it should say that is not a number and then crash. Yeah. Okay. At this point, no, when we can ask again. And this time, we're going to assume the person's going to enter a number. If they speak English. And then we can go on. Now, given that this is another entry, just like there was an entry there, we can increment the counter at this point. And so this time I'm going to start off by getting it wrong. Invalid syntax. But why, sir? Oh, yeah, that's not an if statement. Okay, we're going to say Bob. Ha. 50. Close, but too small. 55. And now I'm going to get 6,000. Oh, number is out of range. But 55 was close and too small. 58. Too big. 57 then. Okay, 5 tries. How many valid tries? 1, 2, 3, 4. Interesting. Aha! So we don't need to increment the counter there because the counter was already incremented once, and then it says invalid guess. So in a way, this counts for that. So if we say too big, and then we say Bob, and then we say 50, and then we go to 25. Oh, 50 was too big and 25 is too big. It's really small. 11? 5? Wow, we got a tiny number. 3, 2, and 6 tries. 1, 2, 3, 4, 5, 6. So there you have it. Those are the 3 upgrades for the Guess the Number game. I hope that you had a go yourself, and I hope that your students have a lot of fun doing these. See you in the next tutorial. Hello and welcome. In this tutorial, we are going to build a basic reaction time game. The whole idea is we're going to try to react as fast as possible to the computer saying go. When the computer says go, we're going to press enter. So in order for this to be a surprise, the computer is going to wait a random amount of time, print out go, we're going to press enter, and then the computer is going to print out. We're going to have a text output for what fraction of a second it took us. I'm already assuming it's never going to be more than a second, reasonably quick. So let's have a think about what needs to go into this program. So we're going to need to import a couple of things. We're going to need to import time because we want that random delay. And since I said random delay, we're going to need to import random. So I guess the game can start with a statement, print when I say go. Maybe, instead of just the word go, we can have a bit of a statement. You hit enter. Got it? Alright. Bit of humor in there. Alright, so I think that's the premise. So how can we make this reaction happen? Well, first of all, you want a random delay before saying go. Maybe you even want to say get ready. So we can do a little delay here. Time dot sleep 1 second, and now we can print something like, ready, time dot sleep. We can do ready, steady, go, but then there's a random delay before the go. Ready, print, steady, and then here comes the random delay. So there's going to be time dot sleep random dot rand int, and we want something like between, I don't know, 2 and 5 seconds. So ready, steady, and then I think we're missing a bracket because of that. And then we're going to print go. So I'm going to print go in a sort of noticeable way. So what did I do? 1, 2, go. Maybe we add some 1, 2, 3, 4, 5. Some more flair here. Now, how do we measure the amount of time it's elapsed before we hit enter? Well, this is just like a neat trick. We can just essentially have a starting point for the clock. So we can say tick. I'll show you what I mean. There is a import time. There's a function that says time.clock. And this, when you run it, is just going to have 0, basically. It'll be something, 1.46 to the power negative 6. But when I call the function time.clock again, it'll tell me how many seconds elapsed. So when I call it again, it'll be 12, so another 5 seconds. If I call it quickly, it'll only be another 3. And if I wait now, obviously, like with, let me show you something. 27, 28, 29, 30, 31, 32, 33. So that's how time.clock works. So all I need to do is take time.clock twice, subtract one from another. So tick can be equal to time.clock. Afterwards, after pressing enter, toc can be equal to time.clock. Obviously, I need to have those function brackets on both. And then time spent equals to toc minus tick. And then we can print time spent. So we just need a little trick here. How do we sense that enter has been pressed? How do we go from tick to toc? And the easiest thing to do, actually, is to just say that some variable is equal to input. It's a trick, but it works beautifully. So there is no actual, outside of using something like Pygame, there is no way to sense if a key's been pressed, other than the input which waits for the enter. So I really think this should do it. I'm going to run it one time, and then maybe we'll clean up. But ready, steady. Oh, what did I do? That was 2.42 seconds. I don't know what happened there. Let's try that again. Ready, steady. Yeah, 0.3 seconds. Not too bad, not too bad. So what we can do is your time was plus time spent, I guess, plus seconds. Now you should maybe run it at this stage. It's going to have an error, but by now you should know how to fix that error. The error is going to be that that's an integer at this point. Sorry, it's a float. It's a number, and we need to convert that number to a string in order to print it out. So let's try this again. Yes. Okay, so it was under 0.3. So as you can see, it's a lot of fun to try and improve on this. I personally can only get as low as about 2.3. But I'm going to leave it at that for this tutorial. I'm going to break this in two halves. And in the next half, I'm going to make the game ask you how many rounds do you want to play. And then when you've played that many rounds, we're going to get the average. So see you in the next tutorial when we do all of that. Bye. Hello and welcome to the extension questions for our reaction time program. So a couple of very, very important notes. First of all, we are using the time library here, and I'm not sure that I said this in the previous tutorial, but the time library actually works with your computer, and therefore it's occasionally not going to work properly when you do Python Online, be that with REPL or Grok. Second is that we are going to be using this list of functions. It'll actually be attached to this tutorial. We are going to use the append list function, which adds an item to a list. So we have a list here with these numbers, and we append 100. So we add that. We're also going to be using min, max, and sum, which basically returns the minimum value in a list. That was the minimum value in the list, the maximum values on the list, and the sum of all numbers on the list. Okay, so now you're going to see why all these are handy. Here are the extension questions. So our basic game has just one timed response. Now we're going to ask the user how many times they want to play. Given that there's going to be multiple, we're going to save those to a list. And then after the user's played however many times, we're going to return to them their fastest time, their slowest time, and their average time. Okay, let's get to it. First, ask the user how many rounds they want to play. Now, probably the easiest way to do that is to just create a variable from input called rounds. Like that. Rounds equals to int input how many rounds do you want to play? 2 brackets to close it. That ought to do it. And at this point, we can just go for I in range 0, rounds. Dun, dun, dun. Put the whole program in the loop. So here we go. We're going to run it. We're going to play 3 times because we don't really want to take too much time with this. How many rounds? We'll say 3. No, not 36. 3. Okay. Ooh, that's a decent time. Wow, practically identical. Bit slower. Okay, so we did play 3 times. That was mission success. Now we're going to save our time to a list. So we need to create a list, and I guess we can call it times, since we're saving our time. And we can go there, time spent. So times dot append time spent. And when we're done, we can print times. So this time I'm just going to run it twice, since once kind of doesn't make sense. No. Uh-oh. What's going on? Back to steady. Ooh. Okay. List has no attribute appends, because it is append. 2. Great, seems to be working. Okay. Those times, aha, your time was 327. And here are my 2 times. That actually works. So here we go. We have a list that records our times. So right now, we can print out those 3. So what did we say? Min, max, fastest, lowest, and average. So instead of printing times like that, we can print dun, 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 dun. I guess that fastest time was, and we can use the min function. Min times. And that could be slowest time was. And I guess what's left, that would be the max, because it was slowest, maximum of times, and the average. Now, the average is the sum of all times divided by, well, the length of the list. So the average time was, and you can do this, because you'd have to turn it to an int, like, you can just create a variable, I guess, here. I think it'd be easier to create it here. Average equals to sum times divided by... Actually, we could just divide it by rounds. You don't need to divide... We could have said length of times as well. Both are completely valid, but you can also divide it by rounds, because the length of times is going to be however many rounds there are. So those are those work out pretty much identical. And since average, we can go average like that. Need an extra bracket. I have a feeling this is just going to work off the bat. So how many does it take to get it done? It takes 3, but I'm just going to do 5. Yay. Let's see how many times I can beat 0.3. Ooh.
That's good. Ha! Error. Fastest time was must be a string, not a float. Ah, I didn't typecast. Silly man. So this could be fixed either by using a comma to print a string next to a float, or it can be fixed by converting this to a string. And frankly, for beginners, for my students, I would suggest that they cast it like this, not that they use the comma, because the comma, in a way, lets you forget that you are dealing with different types and you're trying to concatenate them. And it's a good habit to use the plus. So let's see, we've got how many brackets? One, I think 3 brackets is too many. 1, 2, 1, 2. Okay. I'm gonna run it 5 times again. Invalid syntax, please show me. Ah, there's gonna be 3. I think I'm right. Yeah. Okay, how many rounds do we want to play? 5. That's fast. Oh, that was slow. This is it. Fastest time was 0.2. Slowest time was 0.64. The average time was 0.33. And there you have it. Everything works. Now, I hope that the mistakes that I made there were kind of instructional. I mean, this is a very likely place that things can go wrong for your students. You've got 3 brackets that you need to open and close. This average here can be worked out a number of times, and so I imagine that a number of your students are going to have them inside the string. And also, like, just in terms of practicality, this, yes, would have been easier if I used commas to basically add the float to the print statement rather than converting it to a string, but it worked pretty well this way. And finally, if this looked different from the last tutorial, that's because in Python, the multi-line comment is that triple quotation mark, and then you can write whatever you want in there, and it doesn't touch the compiler. The only difference is multi-line comments are green and the normal comments are red. Okay, that's all for this tutorial. See you in the next one. Hello and welcome. In this tutorial, we're going to learn how to create a ranked list of words from a book. The book in question is actually Harry Potter. I downloaded it for free to use in educational projects from Project Gutenberg. So that's where you can go to get the file, but I'll also include it in the tutorial. Now, how we're going to do this. There is a 5-step algorithm that I've created. I've done this previously. And I will explain it to you first without any code, and then we're going to step through it, and it's going to make sense. Probably the second time, but do have a listen. So first we're going to take this whole book, and maybe I'll just print it. Print text. We're going to take this text that you're going to see printed, and we're going to strip all the punctuation. After that, we're going to convert it into a list of lowercase words. So when the book is just a list of words, like the, comma, zoo, comma, director, comma, when it's just a list of words, I'm going to get rid of all the repeating words and then create a dictionary where each unique word is then the key of that dictionary, and the number of times that that word repeats is the value in the dictionary. Finally, we're going to print out this dictionary in a ranked way, which isn't as straightforward as you think. So let's get into it. So first
of all, let's think about punctuation. I've gone ahead and imported string because there is such a thing as string dot punctuation. If I type it in here, string dot punctuation, there it is. It prints out all the characters that are punctuation characters in the string library. Interestingly enough, sometimes that's not all of them. We're going to find out in a minute. So I'm actually just going to copy that and create a variable called punctuation. And the punctuation equals to that. And then I'm going to remove all of these from the text. And I'm going to do that in the following way. For character in text, if C in punctuation, then we're going to replace. Now, the way we're going to replace C is we're going to say text.replace C with nothing. However, that doesn't permanently change text. So to permanently change text, we have to say text equals to text.replace. And afterwards, we can print the text and see what happens. Print text. It's free of punctuation. Now, is there anything in there? The reason I'm looking is that occasionally there's going to be one weird character in your book which isn't inside here. And in case there was, you would literally only have to paste it, like, to the end of that string. But this seems to... Aha. Wait, that's the old text. This is the new one. Yeah. Nah, it's perfect. So there we go. We have finished the first step. What's the second? Convert the text into a list of lowercase words. Okay. We're going to do this by, first of all, making the text lowercase. Text.lower. And then we're going to go and use this. Text.split. And that splits the text into a list of words instead of a string. And we're going to create a variable here, all words equals to text.split. Now I would, under normal conditions here, print all words. But I know that that's going to be really long and Python might glitch out. So I'm just going to print out 100 words to make sure that this operation is working. It is. Brilliant. So we are 2 steps down. What is the next one? Create a non-repeating list of words. Now, a list of unique words. Let's have a think about how we can do that. First of all, we're going to need a new list, and we're going to call that list non-repeat words. And that's going to be a list. So we can go through all words for word in all words. If word in, or you can say word not in non-repeat words, then non-repeat words dot append. So if the word is not in the non-repeat ones, we're going to add it. But if it is, we're not going to add it. We're not going to do anything. Nothing's going to happen. Word. So the non-repeat words, we're going to be printing that list, and that should be just full of unique words. And it shouldn't be really readable. So we're going to try out if this worked. Print non. I'm not really sure if I should have used a variable that's this long, but we're stuck with it now. Let's go 0 to 50. First 50. Let's see if that works. Harry Potter and the Sorcerer's Stone, Chapter 1, Boy Who Lived, Mr. Mrs. Aha. of number 4 private drive, we're proud to say that they perfectly normal. Thank you very much. So there you go. It kind of is missing some words. Expect be involved in anything strange. So some words are clearly missing, and that does appear to be a list of non-repeating words. Just so you can compare it, that one says say here, and this one says say earlier, because some words are missing. I don't know what words are missing. That's besides the point. I'm just checking the algorithm works. So, on to step 4 out of 5. I think we ended that necessarily. Create a dictionary where every non-repeating word is a key, and the number of times the word appears as a value. So we can, I'm just going to call that dictionary, hey, because we haven't used these very often. That's how you specify that something's a dictionary. And so we can now say for word in non-repeat words. So for each unique word, we're going to say that, like the definition, the dictionary of that word is equal to the number of times that word repeats in the original. So all words dot count word. Let's see if this works. So we're gonna print dictionary. I'm just curious if we can print a limited amount. I'm just gonna try it this way. I'm not sure it's gonna be iterable like that, but let's see. Okay, if we print all of it, it might be a bit long, but let's see. So there you go. Most of these words seem to be repeating once, but see, questions repeats 4 times, hours twice, woken twice, bike 4 times. That's the dictionary with every single word and the number of times it repeats. That's pretty cool. Okay, so we have one final step, and I think I'm just going to refresh the screen right now. If you notice, if you have too much text clunking this, basically your shell can get a bit slow. So final step, we need to figure out a way to use the sorted function to print the ranked value of this, so to print the dictionary in a ranked way. And dictionaries by nature are just kind of random and arbitrary. You have a word, how many times it repeats. There's no particular order. They're not ranked by frequency. They're not ranked by anything. So you have to use the sorted function. And sorted actually returns a list, but you can sort a dictionary. So you can say ranked list, and we can say sorted dictionary. And the key of this dictionary is going to be key equals to dictionary dot get. I think this should work. So if I say ranked list, now that's a list. We can print a slice of that, 0 to 10. Oh, sorry, print. What? Okay, clearly these are not the most popular words. So what I'm guessing is that it prints from the lowest frequency. So it's ranking it by like values of 1 first. So all of these words must repeat only once. So maybe we can fix it by saying reverse equals to true. That needs to be separated by a comma. Aha, the, he, and, was, to, it, his, of, in. There you go. These are the most popular 10 words. Lovely. So now we have a list of the most, but we don't know how many times they repeat. So now we got to figure out how to print the word and the number of times it repeats. And for this, we're going to need a loop. And we're going to need the loop that repeats, I don't know, 20 times for I in range 0, 20. And we can actually determine it by ourselves. The key equals to ranked list I. So the key is going to be the index of ranked list, initially 0. So key, for the first time the loop goes around, is going to be the. So that's the key. Key is the. Next, we're going to find the frequency of the key, which is how many times it repeats, which I think we can just call that value because it's dictionary value. And that is dictionary of key. And now we can print it. Print key plus repeats. Now, value is going to be an integer, isn't it? So it's going to go string of value. So it's going to be the repeats 22. And then we're just going to need times. I think this is going to do it. Let's run it. The repeats, wow, 386 times. He repeats. And Harry, clearly this is the, you sort of figure, you remove the ordinary words. And then you have this. Quite interesting. So, there you go. There you have it. In the next tutorial, will come up with really, really good extension questions where perhaps we can remove the common words or see what happens when we maintain capitalization. But for now, this is a really straightforward, awesome algorithm for how to take a large amount of text and convert it into a ranked list of words. Fantastic. See you in the next tutorial. Hello and welcome to the extended word ranking program. So in this tutorial, we are going to go through the following extension questions. We are going to turn essentially the functionality of this into a set of functions, which are much more convenient, easier to understand and read. So we're going to do a function that creates a punctuation-free word list. It's going to take in a string, return a list with no punctuation. Then we're going to do a function which takes that list and creates a frequency dictionary. And finally, a function which takes in the frequency dictionary and puts out a nice ranked printed table here. After which we're going to do 2 more extension questions that are going to expand on the functionality. One is going to create a mechanism for ranking capitalized words, and the second is going to create a menu. So right at the start, we choose whether we want to rank all words or just capitalized words. So let's get started. I'm going to get rid of all of these comments. We know what things do, and I'd like to keep as much code on the screen as possible. And we're going to start by building these functions. So first of all, we're going to have the, what are we going to call it? Clean word list function, and that's going to take in some text. And I think, it may be easier to understand if I call this text and that text, but that's not best practice in coding because it might confuse you. So this is a parameter here, st. So now all the text is going to get replaced by this
And all words is going to be the variable that stores a list of essentially all words, and that's what we're going to return. So we're going to return, in fact, we can return this. We don't even need to write all words. Return that. Saves us a line of code. So we can go ahead and test this out. We're going to throw up an error, which doesn't really concern me at this point. So we can go clean, we can print clean word list of text. Oh. Yeah, that's going to be huge. Maybe I can just take a slice of it, 0 to 50. That should work. Beautiful. So that there is no punctuation there, everything's lowercase. That's the clean word list. That works. Okay, so what's next? We need to create a frequency dictionary. So this is what we're going to return. We're going to return this dictionary at the end. And I think that barring some variable, return dictionary, variable renaming, this should be pretty straightforward. We're going to call this def frequency dictionary. It's going to take in a word list. And I think we called that all words in the previous program. So everywhere that it says all words, we'll replace it with word list. Non-repeat words. Word list.count. Okay, that looks pretty good. Dictionary. Okay, so at this point, what are we doing? We are starting off by taking in the text. So we're gonna say like some variable, I guess. What are we gonna call it? And we can use all words again. All words equals to clean word list of text. So we feed in the original text into this function. It returns us a cleared out list of words with no punctuation. And then we feed we can call it frequency dictionary, something like this. Frequency dictionary is going to be the frequency dictionary of all words. Okay. I'm gonna frick the frequency dictionary. Yeah, that'll work. So then what I'm gonna do is feed that into the printing function. So I guess I can even put the printing function up there. And what does that take in? I think that would take in the dictionary only. So that would be def print ranked dictionary. And we're going to take in a dictionary. Okay. So let's try this out. So everything that says dictionary we'll replace with DCT because that's the dictionary that we're using. .get. Okay, this should do it. Oh. And finally, we can call this function, and this doesn't need to print because it's got print within it. So we can finally print ranked dictionary of frequency dictionary. And I think I can get rid of all of that stuff, and all the code fits on one page rather nicely. It had this segment here that says print ranked list 0 to 10. I don't think we need that. That was some test code. Let's try to run this. Yes. Okay, isn't that so much neater? You kind of see what we do. We clean the word list, then we take the word list and make a frequency dictionary from it, and then we print a ranked version of that dictionary. That's just sweet. Okay, so I think that we can now go ahead and create a menu and ask ourselves, like, I guess, how many words do you want to rank? That would be a first useful step. So I'm gonna get rid of this down there. I'm gonna create a function, def menu. And you'll see, like, as we write this code, I imagine I'll have to change all of these functions. And that's just iterative development. And that's generally how it happens. You write some code that works, then you write it in such a way that it's really, really organized, and then you add functionality to that. So what do we need to do? We need to ask our user how many words they want to rank. So I guess we can have a variable called total. Total equals the int input how many words do you want to rank. I think we need a space. We need to close that off. And then where does that total go into? That total goes into the ranked dictionary. So if I put the word total there, and then I put the word total here, that should work. All I gotta do is call the menu at the end. Okay, 10. Now, there's a printing here that kind of just snuck in, and I'll have to find it. And it seems to... So if that's total, then when we call print rank dictionary, we have to put tot there. F5, run it again, 10. Yeah, I have no idea how that error happened. That was very interesting. Okay, so we have a successful menu, we have ranking, and now comes the sort of distinction for capitalization. So if you think about the book, there's probably 3 ways, not 2, that we can categorize how we can rank text. We can rank every single word irregardless of whether it's capitalized or not. Then we can rank every single word, but in a case-sensitive way, so that a capital the is separate from a lowercase the. And then we can rank only sort of the capitalized words. I think the first and the third are the most important, but I think there's no reason why we can't do the second either. So let's let's add a menu for that and then have a think about how we can implement it. So what can we ask the user? So 3 options. Print. We can go down the route of print. Come on, print. Okay. So I can say type 1 for ranking all words and ignoring case. That would make sense. Type 2 for ranking all words and being case sensitive. I'm so glad you're still on the screen. And 3, type 3 for ranking only capitalized words. Okay, so we got 1, 2, 3. Those are the options, and we can have our case, and that's going to be the input. So now we can take the case and then make that go inside these functions where necessary. So I need to... I think it may only be needed here, but I'm not sure. So let's start with, I guess, options 1 and 2. So if we add a variable called style here, so clean word list, now that variable is going to go there, and we're going to put in case. Now, what's that style going to do? Yeah, you see that string.lower? That's where we're going to, depending on the style, either lower it or not. So if style double equals to one, then we lowercase it. And I think, so if we do, I think this in itself should work. So I'm going to run it, and we're just going to see. Remember, the lowercase that repeats 386 times. So if I run this now, and then I say style 2, how many words do you want to rank? 10? And I say style 2, 349. See, there were a bunch of capitalized thes. So that worked. That was good. So now option 2, rank all words and being case sensitive. So option 2 works. That was option 1. I'm going to run option 1 right now, and you're going to see the difference. I'm going to say 10 words, and we're going to say option 1. See? 386, 227, 349, 195. Okay, 1, 2. So next up, 3. And 3 is going to be trickier, ranking only capitalized words. So somehow here, we're going to return, or maybe here, we're going to return a list of words that are only capitalized. So we need to create a brand new list. And maybe we can create a menu right at the start. So we can say if style 1, then we can call that if style is 2, we're just going to return the split. And if style is 3, we need to get rid of all non-capitalized words. And I guess that's going to take a little while. So we can create, so it all, well, what are we going to call it? I guess it's not really capitalized words. We're looking for title. So what I mean by capitalized is like, you know, when you say Melbourne. Or should I say like A equals to Melbourne, and then we say A dot is title, which is the function we're going to use. That's true. So we're going to make a brand new list, and we're going to call that title words, and that's going to be list. And then we're going to go through each word in the present list, and the present list is string.split, I guess, for word in st.split. And I'm going to say if word dot is title. So if it is uppercase, then we're going to go and title words dot append word. And then we're going to return title words. Okay, so this is an interesting thing. We have a function and we are returning 3 different things depending on what style we've put in. And so this way we don't have to put, this should work, and we don't have to put the style inside the other functions. I think we kind of cleared up this whole set of options inside the clean word list function. So we want to rank 10 words, and this time we want to rank capitalized words. Yes. So there you go. Just in 10 words you have Harry, he, Dudley, Dursley, Dumbledore, and you can already have the idea of who the main characters in the book are by just having this little distinction and ranking only the capitalized words. So there you have it. That's the extended word ranking program, and it worked quite well. Perhaps just like I did in the last tutorial, for the very end, I'm going to write a comment on each function and describe what it does. So what do we say about the menu? Allows user to select number of words and type of ranking. Clean word list generates a list of words with no punctuation. Takes in 3 options for style, and I guess we should describe it. Takes in 3 options for style. I can say 1 equals to all words ranked, capitalization ignored. Two is all words ranked. We should, instead of capitalization, I think it's easier to say case ignored. Case maintained. And number 3 is only capitalized words ranked. Frequency dictionary creates a dictionary where the key is a word in a list
and the value is the number of times that word repeats. And finally, print a ranked version of the frequency dictionary. I guess you can say parameter total chooses how many words get printed. That's it. There you have it. See you in the next tutorial.
Well done! You have completed a majority of the course already. So, by all means, check us out at headstartacademy.com.au. There are lots more free resources. There's also an Eventbrite page down below where we have regular webinars. Join us and comment below if you would like to participate live as a panelist in one of the webinars. See you later.
Hello and welcome. In this tutorial, we are going to discover some palindromes. A palindrome is a word that's spelled the same forwards and backwards. Mom, whether you read it M-O-M or reverse M-O-M, mom's going to be mom, Eve's going to be Eve, Hannah's going to be Hannah, Bob's going to be Bob, and so on and so on. So what we are going to be doing is we are going to be introducing a new file, which is downloadable for you guys. It's a file called All Words. It's a pretty, I got it off GitHub. It's a much larger list than pretty much any dictionary you'll ever pick up, and it should contain a vast majority of the known English words, so somewhere above 95%. So it's a very, very comprehensive list in English language. We're going to process it a little bit, and we're going to process it by removing all punctuation and lowercasing each word. This way we can test using the reverse function that comes from the exercises whether the word is the same written forward and backward. If it is the same being written forward and backward, then we can add it to the list of palindromes. So to give ourselves a rough outline, maybe not even in sequence, of what needs to get done, I'm going to outline it here. 1. Convert file to string. 2. Strip punctuation. Then we're going to need, 1, I guess this is going to be 2, this is going to be 3. After we've done that, we need to sort of split, or maybe lowercase, everything, then convert to list. So after we've done that, we're going to need a function, and this you can basically copy and paste your one from the exercises. Then we're going to write a function, reverse word, and 5, check if word double equals to reverse word. If so, add to palindromes. So that more or less is our algorithm. And the way that I see it, that there is a function, that there is a function, that there is a function, that may or may not be, but we can write it as a function. And once we're done, we should have a list of palindromes. So let's get started. Very first thing, so convert file to string. I mean, we're just gonna do what we did before. We need to get the name of the file, and I think it's called All Words with a capital W. So text equals to open, and this is going to be allwords.txt, and then text equals the text.read. And that should do the first step. So strip punctuation. If we write it as a function like this, def strip punctuation, and I guess we need to have an input. That's going to be a string. Now you can write the word pass just so that your code compiles even after you run it and the function is empty. So we're going to have a function that strips punctuation. We're going to have a punctuation, we're going to have a function that lowercase a list. Lowercase list. And that's going to have an input of a string. We're going to have a reverse word function, and it also is going to take in a string. Reverse word. And we're also going to have a def check palindrome, and that's going to take in a string. So this is what our program is going to be made out of. And this is, a good approach to sort of start breaking down a larger problem. So if we can have, as I suggested before, you can have like a main function, def main, and this is where your program goes. You call that function at the very end. We here have a structure that's going to work. So the very first thing we're going to do is strip punctuation, and this is we're gonna have a very useful thing here, because in our definition of punctuation we have a list of characters that are punctuation in Python. So we can now say text equals to strip punctuation, and we're going to say text, and text equals to lowercase list of text. So we, by this point, will be able to produce that purified list of sort of lowercase words. And at this point, we can maybe print a portion of the text just to make sure that our program works so far. So what I'm going to do now is I'm going to write these two functions, and I'm going to start with punctuation. If you haven't noticed, this is what I copied. So, oops, I said cut. I really should say copy again. So right here, I'm going to say punctuation equals to that. Now, I really need a quotation mark at the start, quotation mark at the finish, and from here on in, I should be able to strip all of these characters from the text using the string.replace. So for character in punctuation. So for each one of these, we can change the string such that that character is replaced by nothing. So string equals to string dot replace that character, and it'll be replaced by nothing. So then we just need to return the string. That ought to do it. Next up, we can lowercase the string. It should be pretty easy. String equals to st.lower, and convert it to a list. st equals to st.split. And then we can return that string. So if this works, we should be able to, by running this program, kind of get like 100 words on, and that's a problem. Where is it? Text referenced before assignment, but which line? Line 31. All right, so main. Yeah, that is. When a variable is outside the function where you're referencing it, you have to kind of say, oh, global. That means it's been declared at sort of the earliest indent, and now it knows that that is referring to sort of that text variable here. So I think this should work. Yeah. So these are the first 100 words in the list. As you can see, everything is lowercase. As you can see, there's no punctuation. So beautiful. We have processed our list so that it is ready for reversing. So in terms of reversing a string, I'm just going to recycle my solution from the exercises. No need to go over the same thing twice. If you haven't done it already, I suggest you can have a look at my solution. Use yours if you have done it. Essentially, this just turns any string upside down, right way round. So maybe I can just show you. So if you want to do reverse for a particular word, I don't know. We can go for America. Kirima, America. There you go. So that is the reverse function. So I think I've somehow deleted my reverse a string. So that was number 4. Okay, so finally we need to check that the word and the reverse word are equal to one another. So here we go. For word in and this was really going to be a list, and I'm going to change that to LSD. Or word list. For word in word list. If. Now, we need to avoid single letter words. So first of all, if length of the word is greater than 1. If it's greater than 1, then it's a valid candidate. Then we go if word is the same as reverse word. Then we can palindromes.append. Well, we don't have a list here, so I guess we can return palindromes is going to be a list, and we can add to that list word. And the function can then return that list. Okay, so time to test this out. So we have a word list going in, and we have a word list going out. So this really should work. This function is actually using that one. So it's not really going to make a difference, but it could be arranged so that it's done first. Since the Python interpreter is going to read through everything before it gets the main, it doesn't matter. But in fact, we're going to be using only this one. So all we need to do is just add check palindrome to text. And the text is really, at this point, we printed a text. The text is a word list. So maybe, just maybe, I'm just going to call it words. And this is going to be word. So we're going to check the palindrome. And this should do it. Let's see. Uh-oh. of course, we might have actually pulled it off. The only reason is we've never printed out the palindromes. So that's what's being returned, and we need to print that. So we can go print, check palindrome words. And there you have it. Let's see anything unusual. Abba, abba, aga, Allah, Allah, ama, civic, dad, eke, eek, ere, gag, cook, level, madam, radar, pop, boop, beep, noon. A lot of kind of funny words that babies would say seem to be palindromes. There's fewer than I imagined would be there, and some of them I'm really shocked made it onto the list of English words. I mean, I is like the number 3, but what is igigi, igigi? Nonetheless, this is a useful lesson in terms of you have a really well represented main function, which basically says, hey, we're going to strip punctuation, we're going to turn it into a lowercase list, and then we're going to check that list for palindromes. And that list being checked for palindromes is right here. It also uses the refers function, which we have imported. Okay, that's all for this one. See you in the next tutorial. Hello and welcome. So in this tutorial, we are going to learn a little bit about encryption, and we are going to have a look at an algorithm that we will use later on with Python to create a Caesar Cypher. This brings about a question of what is a Caesar Cypher? Well, over 2,000 years ago, when Romans were conquering most of Europe, they had to pass a lot of messages in between, generals and commands, and a lot of these messages got intercepted. But when they got intercepted and the enemies got to read them, the messages were just gibberish. And this is because Romans used an encryption technique, which is named after Julius Caesar. I'm not quite sure if Caesar himself invented it, but it's called the Caesar Cypher. So, here's an example of what a message that has actually very important meaning would have looked like. Total gibberish. So how does it work? Well, the whole idea is that each letter in a message is actually a shifted letter. Now, you can think of an alphabet as a sequence, and you can then imagine a particular letter in a normal alphabet being shifted by a certain number. So let's say if that shift is 3, the letter B will become, so you'll have, when shift is 1, B becomes C, 2, D, 3, E. So with the shift 3, B becomes E. And as you can see here, C becomes F, K becomes N, and so on. So back to the gibberish message from the last page, which is written right here. If we just start looking at this normal translation to ciphertext, the ciphertext has this shift of 3. So here we go. What does WKH mean? Well, here we have it. W in ciphertext means T, K, K means H, and H means E, the first word is the. And if we do this for every single letter in this message, we were going to get something quite meaningful. The advance will begin at 3 p.m. So how do we look at creating an algorithm which can do this for us? Well, first of all, we're going to need to take in and store a message from the user. Then we're going to need to take a desired shift, because you don't want to use the same shift. People may figure out that there's a pattern, so you want to change the shift with the message. Then you're going to need to create, and this is the key bit, a dictionary which can translate between normal text and ciphertext. In a sense, inside Python, you're going to need to create this table. You're going to need to go and create like a dictionary. A dictionary has a key and a value. So D corresponds to A, and you're going to have to go all the way A through Z. Once you have that dictionary, we're going to use that dictionary to encrypt a message. Convert it letter by letter from normal into ciphertext. And then we have a ciphered message. Now, more an algorithm which is more close to code looks a bit like this. So we are going to do this problem in 2 stages. The first stage is creating that dictionary, and the second stage is using that dictionary to swap letter by letter from normal to ciphertext. And the way we're going to create a dictionary is we're simply going to take an alphabet, and we're going to record a shift from a user and then create a dictionary where you have alphabet letters and their corresponding values. Now, once we have that dictionary, it'll be, a loop and several if statements. So we're essentially going to read the first letter of the message. Is it in the dictionary? Replace it with the letter. Now, if it's not in the dictionary, we're going to replace blank spaces with blank spaces, and we're going to replace other symbols with blank spaces. So we're only concerned ourselves with letters. I think I summarized the problem and the way to solve it, and it's a fairly ambitious project, so let's get onto it. Hello and welcome. In this video, we are going to cover the first stage of the 2-stage process of basically creating our own Caesar Cypher encryption. So in this stage, we're essentially going to replicate the Caesar Cypher wheel, and maybe I can show you that. This is what the wheel looks like. This is like a digital simulation of it. And it basically tells you that, oh, look at that. U is A, U becomes A, V becomes B, W becomes C, and so on. So you shift this wheel however much you want to shift it off of the center. And then what you have is a translation of any letter to a shifted letter. So this is what we're going to need to do. We're going to need to create an alphabet. I think I've already got that in pre-written code. Record a message from a user, record a shift from a user, and then create a dictionary showing each letter and its corresponding letter. So let's get to the code. So here we are. We have a pre-written alphabet, basically a list of all the letters A through Z. So what we're going to do is, just like we mentioned earlier, we are going to take in a message and a shift from a user. Now, we're only going to use the shift in this program, but nonetheless, we're going to need a message for our future program. So the way we do that is you can create a variable name, and I think like input string or message is just fine. So if we have a variable called message, and message is the input, this means whatever it is that the user types in. So this is the message we're going to give to the user before we record the input of the user. Write a message you want to encrypt. So that's that. Next, we are going to take in a shift from a user, which we're going to do this way. I'm going to say shift equals to input. Now, because the shift is going to be initially a string, we're going to have to convert that to an integer, right? So what shift do you want to use? So at the moment, the shift is a string, and the way we can convert it to a number is shift equals to int of shift. So that's that. We can, just to make sure everything works, we can print message and print shift. F5, run this thing. What message do you want to encrypt? Dun, dun, dun. Okay, so this is where we definitely want to add some space. YOLO So it prints out the message and the shift. So it definitely saves it. It's definitely going to work the next time. So what I want to do right now is I want to cycle through the alphabet. And the way I want to do that is like this, for I in range. So this basically sets up a loop that goes from 0 to 26. And for each one of these, we are essentially going to have a letter, and then we're going to have a shifted letter. So right now I'm going to just say we have a letter, and the left letter equals to alphabet I. So it takes the ith number. So it basically, it starts with a 0, and the first letter is going to be index 0 of the alphabet A. The next letter is going to be B, C, D, all the way to the end of the alphabet. So I'm just going to show you this. Print letter. So when I run this, remember, this message doesn't matter what it is. We're not using it yet. Even the shift doesn't matter yet. So we're just going to basically see A through Z. That's it. That works. So what we're going for is to have A equals to whatever letter it's equal to. If we have a shift of 2, A is going to be equal to C. So next up, we're going to have a shifted letter. And shifted letter equals to the alphabet, dun, 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 I plus shift. Now, that's going to work partly. I'm actually going to print the letter, and then I'm going to maybe go plus. So we're going to have some space equals to plus shifted letter. I'm going to run that again. Message that we want to encrypt, anything. Shift we want to use, this is important. It should say A equals to C, B equals to D, and so on. Right. So it works up until we get to Z, and then index is out of range. So there is a pretty neat way to fix this. So what we do is return it to 0 when we get to 27. And the way to do that is actually to just take the alphabet of I plus shift remainder 26. So what this is going to do is when we get to letter 27, it's going to be 27 remainder divided by 27 divided by 26, the remainder of, which is 1. So when it gets to the end of the list, it is going to go back to 1. And obviously, 1 divided by 26 remainder of is just 1, 2 is 2, 3 is 3, 4 is 4. So this should fix this, and we should see Z. We should see a return to Y equals to A, Z equals to B. Right now, we don't have a message yet, so it doesn't matter. Shift is going to be 2. Y equals to A and Z equals to B. So that all works great. So what I want to do in the final step is use a data structure called a dictionary. Now, for example, a dictionary, like the dictionary in the real world, is something that has a word and its definition. In Python, the word is called a key, the definition is called a value. So if we have a dictionary, and that's D right there, we can say D of the word apple. And by the way, I don't know if this is a great definition of an apple, but I can say tasty fruit pie. And I can say D of maybe some other word. Kangaroo. Dun, 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 equals to jumping animal. Okay. Not the greatest definitions in the world, but right now when we print the dictionary, apple is tasty fruit, kangaroo is jumping animal. So just like that, what we want to do is, for example, if we've done the shift
for 2, we want the dictionary definition of A to be equal to whatever that was, C. So now when we print the dictionary, apple is tasty, fruit, kangaroo, jumping animal, but A is C. So we want to create a dictionary, just like this list here was saying A equals C, B equals to D. We want to create a dictionary that does that. And the way to do that is we can have a dictionary. We'll just use D because that's what we used a second ago. And just like I did D of apple equals to tasty fruit, we can say the D of dictionary definition of the letter is whatever the shifted letter was. So in the end of this, we can print the dictionary, and hopefully what we're going to see is this in a dictionary form. Message, there's none yet. Shift, okay, let's try 5 this time. Yep, A is F, B is G, C is. So here you are. We have that essentially Python-esque form of that cipher wheel that we had to play with. And now we are ready to go to the next stage where we will be creating a program which is going to use this dictionary to encrypt a message. Hello and welcome. So in this tutorial, we are going to encrypt messages that we type in. So we're going to put in a sentence that makes sense. Hello, how are you? And it's going to return, I don't know, some weird letters that are all shifted. So we have most of what we need. We've got that dictionary that works correctly. We have a shift. We have a message from the user. So right now, all we got to do is read that user message and shift each character in it. So the way we can do that is for letter in message. And just to show you what this is going to do is I'm going to say print letter. So we're going to type in a message, and this is going to print each letter in that message. Then we're going to reconstruct a new message, shifting each of these letters and putting them in something that we're going to call, I don't know, we can give it a name. Ciphertext is actually the correct term, and ciphertext is going to be a brand new string. So let's just run this thing. I don't think we need this line anymore. This already works. And we don't need to print the dictionary. I'm going to assume from now on that the dictionary is going to work. This is the message I want to encrypt. What shift do you want to use? 5. So there you go. So this is letter by letter, and we would now like to change what that letter is. So we're going to say letter is now going to be dictionary of letter. And now we're going to print the new letter. So you're going to see, write a message we want to encrypt. This is the message. Okay. Watch. Shift 5. Okay. T becomes Y. H becomes M. Aha. So we have a problem. The problem is it can't shift space. Space is not in the dictionary. So we only really want to shift letters that are in the alphabet. So we only want to do this if letter in alphabet. So right now, this is what we're going to do. It's going to ignore spaces. And if it isn't, yeah, just watch. I don't know, we're going to try one word, and it'll print the letter and then the shifted letter. Word I can think of is mouse. Shift 5. So M will become R, O will become T, and so on. So all I got to do now is construct the shifted word mouse. And that's easy. We just say ciphertext equals to ciphertext
text plus letter, which is now shifted. And when it's all over, we can print cipher text. And I think we already have a working program, except, of course, that it's only going to be working for single words and it has problems with spaces. But mouse, now let's use 8. Cam. So there you go. M-O-U-S-E. Mouse. Yeah? So I can get rid of these prints because they work. And now we can work on what do we do when we have spaces, what do we do when we have capitals. So let's give this a try. First thing I want to sort out is spaces. I'm going to run this, F5. This is my message. Shift, I don't know, 1. And as you can see, it just prints it in one line. We want it to maintain spaces. So if the letter is not in the alphabet, that means else, then we will just add. See, if the letter is in the alphabet, we're going to change the letter. And if it isn't, we're going to let it stay the same. So I'm going to explain this. So the spaces will be maintained. This is my message. So the spaces will be maintained. But also, letters that are not in the alphabet, these guys, they're not going to get shifted. Even capitals, this. None of that stuff. Shift 9. As you can see, this stuff does not get shifted. And if you want to shift capitals, well, there's 2 ways we can handle that. You can lowercase the whole message up there, or alternatively, you can just say, well, if the lowercase of the letter is in the alphabet, then the new letter is the dictionary of letter.lower, which means you're going to basically get a lowercase output. So I'm guessing it's probably just easier to lowercase the whole message. And the way we do that is message equals to message.lower. So no matter how many capitals you use, you're always going to get a shifted lowercase output. So just to show you what's going to happen now when we've lowercase the capitals, shift, we'll use the same shift, whatever that was, 9. As you can see, this has been lowercased and CQRB, and it's also shifted. Numbers are maintained, numbers remain the same, so numbers are not shifted. And that's that. We have a working code that encrypts whatever we type in using a Caesar Cypher of our own choice. So that's all for this video. In the next one, we are going to break this encryption using a brute force method. So, see you then. Hello and welcome. In this tutorial, we are going to do brute force Caesar Cypher decryption. As you might have surmised, there are only 26 possible encrypted outputs of a Caesar Cypher. So there's only 26 possible messages. In the end, it's probably the easiest thing you can do to print out all the 26 solutions, and one of them will stand out clearly as English. So to run this test, we need to give this thing a message that it can encrypt. And what I'm going to do is I'm just going to go to Wikipedia, and I will paste an article, something like this. And what we're going to do is try to encrypt that. And there it is. And then we're going to try to break that code with all the 26 possible solutions. So
the way that's done is, as you can imagine, the shift is now irrelevant. We're going to use 26 shifts. And this part, where we print the ciphertext, this is where we encrypt the message. This is going to get done 26 times for shift in range 1, 26, because one of the solutions is actually the message itself. So that really ought to work. So let's give that a try. I'm going to copy this message, and I will put it as an input for this program. Shift is not defined. Right. So I think that the dictionary creation has to happen 26 times as well. So what we do is we shift that there, and given that the ciphertext needs to be created as well as the dictionary 26 times, that's going in that loop as well. So right now, let's have a think. For each shift from 1 to 26, actually the upper number doesn't count. So from 1 to 25, we're going to create a dictionary, and we're going to create a ciphertext. We're going to create that shifted dictionary, and we're going to print a shifted message. We're going to do this 26 times. If this works, we should be able Control C, we should be able to see one of these gobbledygook things clearly stand out because it's in English. Oh, right. The yellow hammer is Eurasian bird, and the bunting family has been introduced. So there you have it. These are all of the solutions. And if you just scroll down, I think the English one is just going to pop out. Boom. Right there. So that is the easiest way to break through Caesar Cypher. In the next video, however, we are going to do an intelligent way, which is only going to return one single solution. So for that, I guess we can have one of these inputs and just use the same text, but with a different shift. A shift we don't know. So maybe we'll take something like that. Okay, see you in the next video. Hello and welcome. So in this tutorial, we are going to take our decryption to the next level, and we're going to attempt to do smart decryption. And what that means is we're only going to provide 1 out of the 26 correct shifts. So essentially, we're going to take in any one of these shifted messages and translate it straight into English. And the way we're going to do that is that we're going to take all our output and check how many of them have a high level of matching against the words in the English language. To do this, we're using this file I got from GitHub that has all the words in the English language and done in adjectives and so on. So it's all basically formatted into like one big string. And biologically, etc., etc., etc. This is like nearly 5 megabytes large. So it contains, as I said, probably, given the variations on the word, something like 1 million words. So to load that list of all the words, we are going to do this. We're going to say words equal to open words.txt, and that is referring to the file which is in our folder. So wherever your smart decryption file is, you have to paste the words file right into the same directory, into the same folder. And after that, we just say words equal to words.read.
So right now, what we have is a list of all those words. It's right there. And we can say, for example, when we have an output, a ciphertext, we can check how many words are in the list of words. So what we can do once we've created a ciphertext is to create another variable called word list. And that's going to be ciphertext dot split. And that's going to basically turn our encrypted text into a list of words. So I may just print that out just to show you how that works. So if we run it, I want to go for a very short one in this case. That's our message. And it creates, as you can see, GTJ, that's shift 1, shift 2, shift 3. So it creates 26 different lists. And now what we can do, that we have this word list, is simply calculate how many of those words in that shifted text are in our list of English words. So, for word in word list, if word in words. So if it's in the words, we can have some type of score go up, and I don't know, we can create this score right outside the loop here. So we have a score of 0. And if the word is in the list of words, like if it's in these English words, and I want to change this word list to cipher list, I think it's more intuitive. Cipher list. For word in cipher list, if the word is in words, then we can get a score equals to score plus 1. And now that we have some kind of a score, every time for every word that is in there, we have a score over 1. And finally, we can say if score divided by the length of the word list. So let's say we have 100 words, and if the score divided by that 100, for 0.8, it's going to be like 80% matching. And if that is greater than, I don't know, 0.5, half the words are in there, then we want to print the word list. So right now, I have a feeling that this should work, although we may need some conversions, like is this score divided by length of cipher list, like is if that's going to process, because that's going to be a floating point right there. But let's have a look. I'm going to take this shifted text and I'll put that as an input, and we'll see if this whole thing works. Message we want to encrypt, that's our message. It's thinking. And it's an error. Word list not defined. Well, we used word list after I changed it to cipher list. Print, and we're not printing the word list. We are printing cipher text. And I think it got to the end, right? It got to the end. So I'll copy this. I'm very optimistic. It might take a few seconds. English, English, English. There you have it. So
right there, it went through all the 26 possible solutions and it counted how many words in those solutions are actually in this list of English words. And the only solution that had more than half the words in there was the correct one. So there you have it. That is intelligent Caesar Cypher decryption. Thank you very much and take care. Hello and welcome. So in this video, we are going to escalate to the next level of the arms race of encryption and do something called a polyalphabetic cipher. Now, it's worth explaining what a polyalphabetic cipher is. Essentially, you have a password, each letter of which represents a different shift. So, for example, if we said our password was snake, that password is essentially 5 different shifts. The first of which is S, which is 18. The second is N, which is 13. The next one is A, which is 0. Then K, which is 10. And E, which is 4. So essentially, you're going to use these 5 different shifts again and again and again. So it's going to be, you're going to go letter by letter through your string and shift them by these shifts. So if we were going to shift a word called mouse, this takes a little while by hand, but you would go first M would, you would get this wheel onto 18 to a S. So A would become S. Oh la la. Let me get this back. Ciphertext. So letter M, L M M, M would become E. And O would become G. Oh no, because 18 is the first shift. Then you would have the next shift, which is 13. And for 13 shift, you would translate the letter O, and that would be B. Then you would have a different shift again, which has got no shift, which would be 0. So that ought to be pretty easy. A would be A, so M-O-U, U would remain U. But after 0, we would have 10. 10. So that would be S. P-Q-R-S would become C. And finally, we have a shift of 4. Should be pretty easy to imitate. And letter E, which would become I. A bookie. So that is a polyalphabetic cipher, and that is very hard, if not impossible, to break by hand. In fact, it was about 800 years that people tried to break polyalphabetic ciphers until something called frequency analysis came along, and for each language it sort of counted the number of times each letter repeats until they kind of figured out the length of the passphrase, from which point on it's pretty easy to break. Now, let's get on to creating this as a program. We are going to start, I suppose, by asking the user for a password as opposed to a shift. So password. What password do you want to use? And we can have that password lowercase. And because we're going to have like a word repeating again and again and again, you really want that password to be really long. And the easiest way to do that, to have it recur,
instead of just snake, it'll be snake, 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 is whatever the length is of that input string. You can say password times length of message. So that's going to be like, if it's 5 characters long, it'll be 5 times longer. It's not really a lot of processing power at all, so we can just create it this way and be done with it. So that ought to work. We also are going to have cipher text. That's going to be our string to store the answer. So let's get started. We are going to go letter by letter in the message. 4 letter in message. Remember, we're only going to shift letters that are in the alphabet. So we first have to say if letter in alphabet. And just so that we are clear that everything's going well, we can print the letter. And what we also want to do in here is define the shift and define the cipher letter. So I'm guessing defining the shift is going to be perhaps a touch easier. So the shift is going to be whatever the position in the alphabet is of that first letter in the password. So to say the first letter in the password, I would create a variable here called count, and count can be 0. So the first letter in the password is password. I'll just print it here. Password count. So this is like an iterative password letter. I'm just going to test this out. Message encrypt, it'll be Bobby, and password will be password. So it should just press, it should print B followed by P, and then O followed by A. Yeah. Because count doesn't iterate. Yeah. So at the end, we're going to go count equals to count plus 1. So it'll be B followed by P, O followed by A, B, password. Yeah. Okay. So what I want to do is to define shift, and that, if that password count is the letter of the password that we're on, then shift equals to alphabet dot index of that letter. So now I'm going to print the shift. So I'm just going to go with snake because I kind of remember. So S is 18, N is 13. Let's have a look. So it should be, if I say Bobby, it should be B followed by 18. Yeah, O followed by 13. Good. So we've already got the shift. So right here we have a shift that we're going to be using. It exists as a variable. Variable works. We really don't need that letter. We were just testing. So we're going to try to define the cipher letter. And to do that, I guess we first need to get its alphabet index of the letter that we have, right? So letter index should be just alphabet dot index of the letter. And then print letter. Okay, so this should be, right now we know that the shift is good. We've already forgotten about shift, but right now, for the message, B followed by O, so B should be 1, 1, 1. So there should be 3 ones in, and fine, I'll print the letter again. So it should be B followed by 1. Who cares? Yeah. Good, good, good. So the letter index works. So to get the cipher letter, we want the letter with an index that is bigger by shift. Ta 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 ta. So cipher letter. Dot index letter index. No. Shift. It's not alphabet.index. It is the sort of alphabet position of and of course we're going to need that percentage 26, but let's try this. So if you have a word beginning by A, animal. So A, and if we have snake, so A should turn into S. Yeah. No. Snake. So A becomes S, and then N can't because it's out of index, and then that's solved by that percentage 26. So you start back at the beginning of the alphabet. So this really ought to do it. This really ought to do it. F5, animal, snake. So A will become S, A will become S, N will become A, I will remain I. Because A, S and A, the shift of the third letter is 0, so I will remain I. There you go, it works, the cipher letter works. So if the cipher letter works, then we just need to say ciphertext equals to ciphertext plus cipher letter, and we're done. Okay, could that be it? I think we're not accounting for spaces yet, but that's pretty good. So I'm going to print the ciphertext in the end. And I'll get rid of these print statements because we don't need them anymore. F5, enter. Yep. A will shift to S. I will remain the same. And D, L is going to go back to 18. Looks correct. Now, here's the problem. This is my message. Pa 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 pa. We don't have spaces. Easily handled, easily handled. We just say here, we say else. So if the letter is not an alphabet, we are going to add the letter. So spaces are going to be included. The count happens either way, right at the end. And the ciphertext is there. I didn't think it would take 13 minutes only, but there it is. So this is my encrypted message. Snake. There you have it. A working polyalphabetic cipher. And I think that, if your students are fairly advanced at programming,
then this is a really, really fun cryptography problem. In effect, this is what the Enigma machine was solving, and this is what one of the first, supercomputers, so to speak. No, it wasn't a supercomputer, but one of the first really computers of significant power was developed to actually do. It was developed to work on this very problem. So there you go. Fairly prescient, fairly important. Okay, take care and see you in another course or tutorial.